Let's just go ahead and put us here. And I guess we could do the mic test, Mark. Okay. To make sure everybody hears us. People in the chat, that includes Elliot and DD and MMT and Echelon, let us know if we're even, if Mark ever says a word.
I will say a word.
Let us know that we're even. Let us know if we're low, if we're popping, if we're doing anything, or if it sounds good. Let us know.
Yeah, well, just look at your output levels.
Let us know. Yeah, that never is correct. Ever. Mine can be dead on, and I'd be on the thing like this, like totally, it just never knows. So let us know. Let us know how the voices are. Let us know how, make sure the music's not drowning us out, making sure we're louder than the music, all that good stuff. Let us know, peeps. And hello to everybody jumping into the chat.
Are there marshmallow birdies here? Is that what those are? Peeps?
Yep. The peeps are in the hizzy.
All right. The hizzy. What's that?
The peeps are in the hizzy. And nobody's letting me know anything.
I see we have Jenny here. Hey, Jen.
Hello, Jenny. Hello, Dee Dee. Hello, Elliot. Hello, Echelon.
Okay. Elliot's here twice.
See, it's darn near real time, isn't it? You said hello. It is. We're let's see. The stream is at 10:06 even. Yeah, so we're about 10 seconds. That's not bad. Everything sounds awesome. Thank you, Jenny. Somebody finally gave us an answer. Y'all gonna learn something tonight, whether you want to or not.
I don't know anything. I want to learn too.
It's just me and Mark hanging out tonight, since he has a broken camera problem.
Oh yeah, don't even remind me. SkyTour live stream is down for a week or two because of the HDMI output on the camera, the very, very fine, sensitive camera that takes the imagery to the internet has crapped out. And so after pulling out my hair today, and now I'm bald, but don't worry, it'll grow back. So I got a warranty repair coming, and I'll be able to send it in tomorrow and get it repaired. I do have another camera with HDMI out, and I'm thinking that maybe I could do brighter objects with it in the interim. So I may try that as well, just so I don't have to be down and out for the down for the count. But we'll see what happens.
Amen.
Yeah.
You're back up and at it in no time.
Yeah.
Now, we do have a resident. I'm pretty sure she will show up sometime tonight, Mark. I will let you know that there is a little lady by the name of Foxy that does come into this stream. She is 8 years old.
Really?
And she is obsessed with the moon, and we have designated her our future resident astronaut.
Awesome.
So you might see questions from her.
That's fine.
David Schmidt's really been helping her out a lot with some of the questions that she's had.
Yeah, Jenny, you're right. The moon does look fantastic.
But really, really bright little cookie.
Yeah, that's nice. One. Yeah, I like that.
So
you know what? I have a thing that I talk about with little kids. You never know who you're talking to. You could be talking to the next president. You could be talking to the next astronaut, the next Nobel Prize winner. You don't know who you're talking to when you look in those little eyes. Yep. So I always say put your best foot forward and give it your best shot, because they deserve it, and they deserve it because they're going to inherit what we leave behind.
Yep, and that's for any of the mods too that are in the chat. Remember, if Foxy does show up, that she is 8 years old, so sometimes she can be an 8-year-old. You know what I mean? And I'm a little protective of her on this stream just because of her age.
Good for you. I'm glad you. Uncle Keith is going to protect
Yeah,
her.
Exactly. I had to pull out the dad card last night. So, but yeah, she's a cool girl.
Daughter?
What's that?
You mean with your daughter?
No. With I had to pull out the dad card with her last night with Foxy.
Oh, because somebody was.
No, she said something. I was like, don't ever call anybody that.
Oh, okay.
Yeah. So,
that's right, Tommy. It is fat. Look at it.
And if you notice tonight, we're using a 70mm instead of the 80mm. I'm not sure why Paul decided to use a 70mm, so that's what we're going with. I have no say in it.
Well, classically, refractors which is what we're using here, lens-based telescopes deliver the best views of the planets and the moon. You know, mirrors, you lose contrast. There's something lost every time you bounce that, that light. But when you are just bending the light with a refractor, bending it down to a sharper and sharper point until it comes to the eyepiece, it really looks much better.
It's crisp.
It's crisper, yeah. And when you take photographs, using the right telescope is very important. So that's why, like in our Skytour livestream observatory, we now have a 5-inch refractor also mounted on the mount with this 10-inch catadioptric telescope. And we can do video and imagery from both.
Right.
And so that's the upgrade. And now, you know what? It's also cool because we're, in the, I guess, trying to figure out how long it's going to take, but we're getting the automated dome software that's going to be able to move the dome with the telescope. So as the telescope moves, the dome will follow suit. Mm-hmm. So that'll be the last thing that I have to do before being able to run the telescope from inside a warm room and not have to be out there with it. Then I figure out how to connect it to the internet. There's a whole bunch of software to do that as well. And I think I'm about $3,000 from $3,000 from being able to log into it on the internet, wherever it might be, And of course, our goal is to stick it out in Arizona. And you are going with Paul to Devil's Tower.
Yes, sir.
In the end of October. And you're going to be at Devil's Tower precisely the same time. We know this because you invited me to go and I couldn't. At precisely the same time that I'm going to be in Arizona. I'm going to be I'm doing a talk there, and I'm also going to be teaching a class on UFO technology and astronomy, all scientific based, for that week. And so I'll be out there doing that. And I told you. And I'm going to be at Devil's Tower literally earlier.
Yeah, you'll be there like 3 or 4 weeks before us.
Yeah, because I'm doing a talk in there. I'm actually the keynote speaker at the Devil's Tower UFO Rendezvous. I can't believe it.
My.
I know.
I'm still trying to talk Jenny into going with us.
Oh, I think that'd be fantastic.
I think she would love it out there.
You know what, though? I have a feeling that, and this is the thing, Keith. When you get out to Wyoming, and if you get to Hewlett, which is the town that we're based in when we go to Devil's Tower UFO Rendezvous,
right?
You'll meet folks like Lori Tucker, and you'll meet guys like Bob Olson. Bob and Lori are the ones that put together, and Bob's wife. The three of them put together the Devil's Tower UFO Rendezvous last year, and it was the first time they ever did it. And it went very well for the first time.
Yeah.
Now, they tried to take it slow and do it right, and they did it, and they got it right, This year, it's even better. There's an all-star lineup now out there. We got Micah Hanks, we got David Marler, we got myself, which, take it or leave it. We have Lee Spiegel. We have the Wyoming State Director.
Where do you fly into when people fly into Wyoming?
Well, last year... No. Last year, I flew into Gillette.
Oh, okay.
And then this year I'm flying into Rapid City, South Dakota, which is literally the same distance from Hewlett, Wyoming as Gillette. Yeah.
Cool.
Yeah, and it's fun see, Devil's Tower is an interesting place. A lot of mythology surrounding Devil's Tower. Native Americans call it the giant tree stump. Basically, not exactly that, but the translations were that the shape looks like tree bark, and that comes from the fact.
It does look like it.
Yeah, well, it comes from the formation of the tower and the way it formed. Because what people don't realize is the tower never made it above ground. Well, you say, well, wait a minute, why do I see the tower above the ground? It's because the tower cooled in position deep underground, and then the ground eroded away, leaving the much harder, dense basalt lava, hardened lava, behind. And so as the ground eroded away, the tower started sticking up out of the ground. I mean, there was a time when the tower was just a tiny little, 10-foot little bump sticking out of the ground, and then it became an 800-foot tall monstrosity as the ground around it was eroded away in flooding and in weathering and storms and winters. Right. So it's kind of interesting how that came about. So you're actually looking, when you're at the base of the tower, the top of the tower is 800 feet up, all right? And you're literally 800 feet underground from when that thing was formed. effectively. It was actually even more than that because it was below ground a significant amount. And the reason it's that shape is because the basalt lava, when it cools, it forms crystals. Those are crystals. Those are hexagonal crystals of basalt lava, and they're about 10 to 12 feet across, and they're hexagons. And that's beautiful.
Yeah. Sweet. And one thing I do want to tackle tonight, because I realized after our conversation last night that not a lot of people know that the moon actually rotates itself. Yeah, it's tidally locked, but the moon itself does rotate. And I looked around to try to get a visual representation of this so you can understand how this works. So what I did is, while Paul's still on the wide field here, the red area, as you will see, is the area we can see. Okay, and this is what it would do if the moon actually didn't rotate. Now, the red area is the area we see all the time.
Yeah.
So this is what it would look like if the moon didn't rotate at all. And then, as you'll see the next time it goes around, it'll show you what happens if the moon rotated fast. You know, it had a nice, circular rotation to it. Well, that's not what we see at all either. And then what you'll see coming up is actually how the moon actually rotates one time, pretty much, per 27 some odd days. Watch the red area. It's the same face of the moon, and this is how we actually see it. This is why we only see one face of it. See how that works?
Yep. If you watch just the moon, you'll see it goes around once.
Yep.
If you take the Earth out of the picture and just focus only on the moon, you'll see that it goes around once every 28, days or so, right?
Yep. Rotates on its axis once, and the same time it takes to orbit us once. So that's how that works. So yes, if anybody asked you, now you know the moon does rotate. It's just rotating in the same time it takes us to rotate us here on Earth.
Yeah.
And voila. You learn something new every day. And then Paul was setting up the 10-inch the 10-inch telescope in the meantime. And once again, we're just hanging out. With me is Mark D'Antonio. I'm sure most of you know who he is.
Who is he? I don't even know.
Some jerk.
Why'd you even have him on?
Because he's a smart jerk.
Oh, okay.
Yeah, and I happen to learn everything every time you're on. So, it only helps me. Plus, I'm tired and I need somebody that talks a lot.
Oh.
And when I needed that, I was like, okay, I need somebody who talks a lot and I need somebody that can teach people. Mark.
Hello. Hello, computer. Remember Scotty in the Star Trek movie?
Damn.
Computer. Hello, computer. Scotty, use the mouse. And he picks the mouse up and talks to it. Computer. Very funny.
Oh, my.
Okay.
Jeez. Jenny, you can talk a lot too, but you're like full of energy. Like Jenny is like the Energizer Bunny.
I know, she's wonderful, isn't she?
Like when you're around Jenny, you almost can feed off of her energy. Like if you're feeling like sluggish, just be around Jenny. Your batteries will be charged in a matter of 5 minutes.
Auto caffeine.
Yeah, the natural caffeinated Jenny.
Mm-hmm.
All right.
Here we go. We got something happening here.
Yeah, we're switching over to the big dog.
Yeah.
The 9.25.
Yeah. I like it.
I see Kevin wants to explain.
He was. I'll say what Kevin West was talking about because technically he was right. When there's molten rock underground, we refer to as magma. Devil's Tower was a magmatic, and there's debate. Was it an intrusion, into the strata at that point when it was underground? Possibly, but it was magma there. But when it's eroded away, it's now above ground. And when you talk to people and say, well, look, this is magma, but it's above ground now, so we don't call it lava. I mean, you can't go through those definitions. So I kept it easy and just said, look, it's lava. You know, it's magma that was eroded away and exposed is what it was. So that's why he mentioned that, and he was right, of course, about that. So Kevin, you know, props to you. You know, you're right.
Travis just said exactly what I was thinking. Because we don't need liquid hot magma from Dr. Evil. Every time somebody says magma, that's the first thing I think of is Dr. Evil.
And Kevin, you're right. That's what I had mentioned, that it did erode away, exposing the Devil's Tower.
Yeah.
And in fact, that's why we have the crystals that we see. You know,
Ooh,
and they're like 10 to 12 feet across. I got some beautiful photos of people standing on these crystals, you know, about 600 feet in the air. And man, they're very wide. They're also very fragile. And the whole base of the tower is covered. It's called a talus, you know, all this loose rock that tumbled off the sides of the tower. They're actually these crystals. They break on these lattice lines inside the rock, and they fall. And there are tons of rock each time. So when these folks are climbing a tower over their heads, I mean, they're taking a chance. Somebody's going to die from a rock fall there. There have been deaths on the tower. But
hold on, time out, Mark. Do me a favor. What crater is that?
Where are we looking?
Look at your screen.
Oh, on the moon.
Yeah.
I mean, along the rim there?
I forget. It's the one that everybody thinks is a giant laser gun. But it's not. What is it?
That's not Pythagoras.
No.
Because that's the one they think has a giant laser gun in it.
No, that's not Pythagoras. Is it?
And that's the one they think has the giant laser gun in it. Are you talking about Pythagoras?
No, I'm talking about the one on the screen, but I didn't think that one was Pythagoras. No, that's not Pythagoras.
No, it's not Pythagoras.
No, what is that? That's the giant gun one, but that's not Pythagoras.
Okay. Well, let's see. Is that?
Oh, it's one of those weird ones that sounds like a T but starts with a P. Patala,
sure?
potato, tata.
That's not Carpenter?
No.
Okay. Then is it?
My mind isn't working tonight.
Is it Philolaus?
Me and Travis are on the same wavelength tonight. I was literally about to say that. I was like, sharks with freaking laser beams coming out.
Is that Philolaus?
Ooh. Yeah. Oh, maybe.
I'm just trying to see.
I don't know. But just so everybody knows, it's not a giant gun. And if anybody can see my sarcasm in the titling of tonight's video,
actually, I think
it has to do with something that we talked about last night. Where,
that is a giant gun.
Where people were putting live views of the moon recorded 3 months ago.
I think that was Philolaus. He was a Greek mathematician and astronomer, and that was around 400 BC or so that he lived. So that might be Philolaus.
Man, Aristarchus is bright. Jeez. What is the composition of Aristarchus to make that reflectivity? Is it silica?
Well, it's actually, that outflow, that stuff, that ejecta.
Yeah.
The surface layers on the moon, in that area, there's a lot of Maria, and the Maria was darker anyway, and the underlying strata was always brighter. And so we're seeing the underlying strata that got blasted out and laid out as ejecta, especially on the plateau. And in fact, that impact that created Aristarchus actually created this massive bench, all right, on the eastern side, as seen from the Earth, of Aristarchus. And that it almost reaches into, what is it, Herschel next to it?
Boy, you're asking the wrong guy tonight.
Hang on. I can
My brain's on slow motion, man.
No, Herodotus, I think. That's Herodotus to its left.
Herodotus.
It just to its left and lower. So the bench almost reaches Herodotus, and in fact, you can see that the bench is cut off by Herodotus, which actually tells us that Herodotus actually came later after Aristarchus. So you can figure out the chronology of the impacts by looking at these. And cinema skimio, yes. The molten moon cheese. Absolutely correct.
Poor Paul.
Absolutely correct.
Just as he sets up the 11-inch, these clouds come in.
I see that we got something crossing over the moon there.
By the way, anybody that doesn't know, yes, I'm running the YouTube. Yes, you hear me on the microphone. This is Keith, by the way. If Paul has anything he wants to relate to you in any way, most likely you're going to see it on screen below our text and everything up top. Like as you see on screen right now, it just says, just as I set up the 11th, a few wispy high clouds. That is Paul talking to you guys, letting you know what's going on, just so you guys know. Since he's out in the top of the parking garage, you know, roughing it while all of us are nice and comfortable in air conditioning and fans
he's and in the
sitting on our butts.
80-degree heat.
You know what? If it turns out to be clear, I do not put it past Paul to bring out that 12-inch. Because I know we have done really well with Mars and Saturn the last 3 nights. And I know he's itching to get that thing out here to try to get it a little bit better. Because we really rocked those 2 planets the last couple nights.
I'll bet, because I actually saw, I actually looked at Mars yesterday. I was really angry that the camera had died. So to quell my anger, I looked at Mars and took photos. The camera works, okay? It's just the output to the stream didn't work anymore from the camera. So that's what I've got to get repaired. The camera's fine.
Like, oh yeah, camera, I'll teach you. I'll look at Mars anyway.
Yeah, so I did. And I actually saw some dark surface features, and I saw one of the caps. And it was really, really pretty.
Wow,
so
look at that.
I believe it was a northern...
moisture just came in.
I see that, yeah.
We're going to have to go back to wide field for a little bit. I hate to say it, people. But it is not time for the big scopes yet.
That's nice, Chris.
Yeah. Everybody's wondering about the donut. The donut. We don't know.
The other night?
We don't know. We can't positively identify it. We have ideas what we think, you know, how big it was and, you know, if it was solid or actually a donut. My personal view from looking at it, and Mark pretty much came to the same conclusion, I believe, is that it was because the moon in the background of the donut hole, quote unquote, didn't change with the imaging like that was supposed to be behind it, like dark areas and light areas. It stayed the same all the way across the moon. So that when you said you think it's a solid object, I said, well, that's definitely possible. You know what I mean?
That's the only reason I said that is because you would have noticed you'd see some type of tone change when it went across a bright area on the moon. And I actually went over this frame by frame by frame, okay? And I came to the conclusion that it is a solid object, but I think it's actually a transparent object. And I'll tell you why. Transparent, but enough like plastic bag type transparent. And I'll tell you why I think that, and I'm not sure if it's true.
You're just going to kill all of our dreams right now, aren't you?
Yes, I'm sorry.
All right, go ahead.
I'm saying what it could be. I'm not saying what it was.
All right.
Go ahead.
Dream killer.
And Travis, the reason I say this, Travis, is because if you think about it, anytime an object crosses the front of the moon, it should be a silhouette. But because we saw a bright central area that didn't seem to change, it told me that we were seeing light that might have been passing through it from the moon, but not enough so that we could make out the moon behind it. And that's the kind of thing that'd be consistent. For instance, if it was a, let me just say it this way. Say you got a computer monitor. It comes in a plastic bag. Well, if you roll up the plastic bag and take it off the monitor, it's rolled around the edges, but then the center area is kind of still it's crinkly, but it's still somewhat clear. Put that in front of the moon, and you're going to see a ring that's dark around the edges and semi-clear in the middle. Now, you wouldn't be able to make out features behind it, but you would be able to see that there's something behind it. And the fact that we could see light at all says that either it was illuminated from the front side, that is from Paul's location, very, very brightly by like a bright light that was brighter than the moon, to be able to catch like that, because at some points it was as bright as the moon. And that's another key item. It was only ever as bright as the moon. It was never brighter when I did this analysis.
And by the way, I should add to anybody, if I'm going to take anybody's advice, it's going to be Mark's, because he is the lead video and photo analysis guy for MUFON. So he kind of knows what he's talking about. So continue,
Well,
sir.
I thank you, but I don't live on credentials. Actually, you know,
Well, you're going to tonight.
I base it on the science, you know, and I'm an imaging science guy. I'm not a you know, psychologist. I'm not, you know, I'm an astronomer, and as such, we need to look at you know, all kinds of things and sort of be masterful about how we handle this stuff, because, you know, if we just make, say, flippant pronouncements about this, say, being a UFO, then everybody who comes after me, I'm doing a disservice to, because I would not have actually you know, done them justice and done a fair examination of the thing.
Right.
So that's all this was, you know. I mean, I think that I did that, and my feeling is that it was probably a semi-transparent thing, like a plastic bag rolled up at the edges. Why was it airborne? I don't know. That's odd to me. But I'm telling you what it could have been, not telling you what it certainly was. I can't tell you what it was, but I do know that it was definitely something drifting on the wind.
I think I might have identified it, actually. I'm still going with Thanos. You know that big ring ship from the new Avengers movie? That's what kind of reminded me of.
Why did I not think of that?
Did you see the new Avengers movie? The new one?
Yes, I have.
You remember that big ring ship that comes into New York?
I do.
That's the first thing I thought of when I saw it. I was like, oh, great, Thanos is here. We're all going to die.
Yeah, except if you notice, the one thing that I actually noticed about it is when I studied the way it was coming across the screen and I looked at it, it actually turned in profile a couple times.
It turned in profile, and then the direction actually turned upward, which I'm trying to...
Actually,
we were actually off, you know, we weren't correct orientation.
It didn't, actually. It actually came from the middle left and was going at a downward angle to the lower right, and then it leveled off. Okay, it didn't actually go up. That was an illusion, I think. And if you look at it again...
Well, I did a straight line comparison. Yeah, that's the only reason I'm saying. And it actually did go up. Not much. You're right. It leveled off for the most part, but it did actually go up a little bit. Just the tiniest bit. You know how you do those straight lines with the software, and it know, you can tell the little notches when you're not completely straight.
Yeah,
it went up just a tad.
I did the same thing, but it was actually a very little amount compared to how high it was at the beginning of the path.
Yep. Now, size-wise, normally you can get a size from the transit of the moon, right?
Yes, and I'll tell you how that works when it's actually a satellite. When it's not a satellite and it's in the atmosphere, then unless it's a known object, you can't tell whether it's a small thing up close or a giant thing far away.
Then it was Thanos. That's the only explanation.
It could be Thanos, except Thanos was caught in the upper level winds in the ionosphere, and it was just blowing all around.
See you later, DD. I'm surprised DD's not sticking around on a Friday. What is going on in this world?
DDB, what's going on?
I don't know if I want to live in a world where DD doesn't hang out on a Friday. Yeah, Jenny, it was a crazy... I mean, literally, I had my... Because we were kind of joking around at the end. I was playing a Joe Rogan clip, you know, kind of goofing on flat earthers. And I was just about... Like, I had my finger on the button to end the stream, and this thing come floating through.
I know you did.
And I was like, what the... You know, and then next thing you know, we're on for another hour. And It was just crazy.
It was, and I think that's probably the oddest capture you've caught. Although I will say, like I said, I'm pretty much 100% certain. I say pretty much 100%. So pretty much means 99.99, okay? Say not 100. You can never say 100. Right. That it was definitely something floating on the wind here in our atmosphere. I can't tell you how far away it was. It may only have been 1,000 feet away. It could have been, 2 miles away.
Even if it was 1,000 feet away, I mean, that thing took a while to cross the face of the moon. I mean, we're only looking at a very small area of space.
I know. That's also, that doesn't tell us distance. That just tells us speed of motion. And I've seen things hovering in the sky that kind of move lazily along that aren't balloons. Like I saw plastic bags that have been lifted airborne, and they just sort of like drift very slowly. And I was staring at these things for 5 minutes in relatively the same spot.
Yeah,
it just happened that it was caught in the same relative wind stream, and the wind stream wasn't that big, so it just stayed up there. I mean,
I told Paul, I was like, if Mark comes back and tells me that was a balloon, I'm going to slap him.
Nope, it's not a balloon as far as I can tell.
Yeah.
No, I couldn't. I don't think it was a balloon. I think it was actually a piece of debris of some kind. And that's just a thought.
But guys, we got excited about this because
you can't tell the size. I know Jenny thinks it was quite large. It was large relative to the moon,
and it could have been large.
It could have been large, yeah. But it could have also been a smaller object up close.
Which is why I also sent you that video though, with the one from I think it was Germany or Canada.
Yeah, I saw that.
Of the daytime, which was weird because it was circular and the center was illuminated a little bit. Now this was a daytime shot.
Yeah.
And I was like, well, just for I just wanted to play devil's advocate. Like, wow, this, it's kind of weird. It was moving kind of around the same speed, kind of the floaty maneuver that the one that we captured was.
Yep.
And I actually did a search on Google about ring UFOs, and there was a couple that came back that looked exactly like that.
Well, yeah, because they're rings, but see, but the thing is,
they're rings, duh.
I'm not downplaying that, okay? But all I'm saying is, when you look at a ring, what could a ring be? A ring could be bundled material around the outside edge with something relatively clear in the middle.
But it has to be extremely light if it's natural.
Yeah, yeah. And I know exactly, well, okay, you're talking to a guy that actually made hydrogen balloons out of clothing bags. My father owned a laundry, and I'd drive down on my bike, and I'd say, Dad, can I have some of these clothing bags? Oh, yeah, sure. What are you going to use them for? An experiment? Okay.
Daddy's weird.
I would take these, and I made this little still in the backyard that was generating hydrogen from Drano, sodium hydroxide.
Okay, yep.
Hot water.
Way to get the ATF at the house there, Mark.
Well, back then there was no such thing as that there.
What's Daddy doing? Oh, out there putting hydrogen in shopping bags. Nothing suspicious.
No, I put I was like 12. I put metal shavings.
Even worse.
I put metal shavings in this bottle, this glass bottle. It was an old water bottle. From the water coolers in the old days.
Yeah.
And we had one. It was an antique, which probably shouldn't have done this. Shoved these metal shavings down in a notch inside the thing, poured in water to fill just the metal shavings, and took a whole can of my mother's Drano, which is sodium hydroxide, a very strong base, not an acid, a strong base. I poured it into this water and started, swirling it around. It takes about an hour for that sodium hydroxide, a very strong heat up. When you come back, that bottle is too hot to touch. And it's generating hydrogen gas because of the way the sodium hydroxide, which is Na, sodium, and then oxygen and hydrogen, NaOH. Well, the H2O in there, it's liberating the hydrogen.
You already lost me.
Okay, you get hydrogen out of it, and so it comes out. So I was putting that right into the clothing bags, but so was all the moisture getting into the clothing bags from the water vapor that was.
I can only imagine. Steam. Like police driving around, like, oh god, there goes that crazy huffer again.
Oh wait, it gets better because I realized, okay, the bags aren't floating because there's too much water vapor. So I went into my mom. Ma, do you have any of those gallon plastic jugs?
Ma, do you have any thermite?
I think your father has some for the. He has there's chlorine for the pool, which is bleach. And I went, okay, so I took the chlorine, which is bleach. My father again had a laundry, and he took bottles of bleach home from his laundry and used them for chlorine. Obviously, and so I poured these two bottles into the pool, 2 gallons into the pool, and mixed it, as best I could with the filter running. Took those bottles eagerly into the backyard.
You were a freaking terror when you were younger.
Oh, are you kidding me? And then I put a black electrical tape over the mouth of one and the tube coming out of the hydrogen gas generating jug, and I had that plastic bottle filled with cotton, and it was, Ma, do you have any cotton? I think I have a bag of it in the bathroom. Okay, and I took the whole bag. Okay.
Let me answer Preston real quick. He asked, how come for an object that size there isn't a shadow? There's nothing for it to have a shadow on. We believe that it was in our atmosphere. There's nothing that it would have cast a shadow onto. It wasn't near the moon at all. We can pretty much agree on that. It was not near the moon.
No,
it wasn't in orbit either. It was way too slow for anything to be in orbit.
Well, actually, it wasn't, but
it would have burned.
It was actually, we don't know that. It could have been, like I said, a massive object farther out. The trouble is, it wasn't traveling using orbital mechanics. Traveling using wind.
Yeah, wind. It looked like it was floating on a wind current. Definitely. Yeah. But yeah, there was nothing for it to cast a shadow onto, per se. So,
yeah. Hey, Cindy Mosquito, yes, you're right, Cindy Camillo. I also jumped off of high outcrops with garbage bags, thinking they'd be parachutes. Well, that didn't work, so I took several of them and I taped them together because, of course, Scotch tape holds anything, does it? doesn't it? And I jumped off, and guess what? I also crashed into the trees in the same way, you know. So
you were probably the kid that was making like 2-liter bottles of like vinegar and baking soda bombs, weren't you?
Oh yeah, I mean, in fact, I got so many stories. Well, anyway, let me just go back to the hydrogen thing. I just finished that up. So I would make this hydrogen. I made these I call them moisture traps, and these plastic jugs that had the bleach in them that we use for the chlorine in the pool, I filled with cotton. Hose coming out of the generator went into the air. I took another hose out of that bottle into another plastic bottle with more cotton. The more moisture I could trap, the better. And what was coming out at the end was almost all hydrogen. Only a little bit of water vapor was getting in, and now these balloons were buoyant. So I'd cap them off, take 4 hours to fill up one of these clothing bags. I capped them off, ran immediately, took them out into the empty lot between my house and the next house on Winter Street in Plainville, Connecticut. And I tied it off to the ground. And I want like shoot it with a flaming arrow. So I had a little bow and arrow kit, you know, cowboys and Indians thing. I dipped the arrow in gasoline, lit it, fired it at the thing, waiting for this explosion, and it missed. And it hit in the grass. So then I did it again and again. I still missed. So I got closer and closer and closer. And meanwhile, I had to then run around and put out the fires that were now started in this lot.
Dude, you were a menace.
Arrows. Oh, yeah. I mean, I had big patches of black grass after that. And then when I went out, finally, I just got right up to the thing. And I took this flaming arrow and I just threw it at it. And it was only like 3 feet away from me.
Oh, geez.
Wow. That was a mistake.
Dude, take everything you just said and imagine any of us right now, these days, in this day and age, seeing a kid outside doing that. You would call the cops.
Or you'd get a job.
Yeah.
Yeah, well, so when I did this, I threw this thing, and that's kind of all I remember.
Creepy next-door neighbor kid's at it again.
Oh, no, that's all I remember. Because I got knocked on my butt, and I got hit in the chest with this shockwave that just was like, and I just went right down, hit the back of my head on the dirt, and my first thought was, oh, man, I got to do that again. So I ran into the backyard, and, of course, made sure I got rid of the evidence. And, you know, every time that happened, it would rattle windows in the neighborhood. And they'd call the police. So something exploded, and the police come driving down the road, and there I am in the front yard.
God, they hated you.
Well, no, they never knew. Well, now they do. And, yeah. And I did it a few more times. A couple of them got away, and I actually couldn't, because I was getting more creative, and I made them smaller, and it would take a shorter amount of time. And I did my best to try and make them manageable, but unfortunately they ended up getting away, a couple of them, and so I had these hydrogen bombs just flying away, and I never got to knock them down. However, that was cool, but you know, that's one of the many things. I mean, I also did the tennis ball cannons. Hey, you guys in chat, if you remember the tennis ball cannons, how many of you actually did tennis ball cannons? We actually made out of tennis cans where they had tennis balls in them. Take 3 of them, cut the bottoms out of 2. All right, and you stack them, put them together with duct tape, lots of it, and then poke a hole in the bottom can. Wrap a tennis ball in cloth athletic tape, and then push it down into the can, and then pour lighter fluid into the bottom hole in that can. You put a bottom hole in.
Freaking
now you
James.
have a huh?
Oh no, I'm just reading the comments.
Oh, well, now you have a mortar.
Oh yeah, mortars when you're 8 years old, great, super.
No, 12.
What could go wrong?
Oh yeah. Well then, you know, so then this mortar, your mom, do you have shaved aluminum?
Making mortars when you're 12.
So
we'd be on a watch list these days.
Oh my gosh. So we just light them with regular little matches, the little tiny matchbook matches. But every time you brought the match anywhere near that little hole at the bottom of your stack of tennis cans that were like a bomb, the fireball that would come out of the bottom of that can would burn your fingers. So we got really smart, and we started using these fireplace matches that are around 12 inches long.
Oh, sure.
And we light those. And it would just blow the match to pieces, but then you'd see would come out the bottom, and it was a deafening boom, and your ears would hurt, and then you look up, and there's the ball disappearing into the infinity up there.
Mommy, we need to go to the supermarket.
Why is that, son?
We need to get some plutonium.
So I'm making an arc reactor in the basement.
Yeah, right. Yeah,
Mommy, I want to smash particles together tomorrow. Can we get a couple parts from the 5 and dime?
Yes, I need some hydrogen, and I need some plutonium.
I'm working with nanothermite.
And I need a few.
That's crazy, dude.
To control temperature.
I think when I was like 12 years old, I think I was playing in dirt with a Matchbox car. And here you're making like, you know, mortar rounds.
No, I actually I played in dirt with my Tonka trucks.
Yeah, Tonka trucks.
I had this Tonka fire engine that actually squirted water.
Big metal bastards. You couldn't break those things.
Oh, I know. I mean, I used to stand on it, you know.
And like how you would push it across the floor and bash your mom in the ankle with it. They love that.
Oh yeah, she loved that so much. I spent a lot of time in my room or in the cellar with my train set.
God, we lived through some stuff, man.
Oh yeah, fun. And then like one time I remember I was bored. I guess all this starts because I was bored, and I actually was in the backyard playing with this Tonka snorkel fire engine truck, and I was spraying the dirt with the thing. I said, "This isn't realistic. And these things put out fires." So
let's light a fire. Sure, why not?
So I lit a little fire, and it was, you know, at first
mortar everything and put it out.
It was under control at first, and I was actually, I was making the fire truck sounds, you know, and putting it out, and the firemen are here to put out this house, because I actually made this little stick house, and I started it on fire, not noticing that the grass was catching on fire then.
Sure.
And then some bushes next to it started catching on fire, and of course I'm pointing this little tiny, you know. A little tiny spray, this little tiny thread of water from this snorkel toy truck at this gigantic conflagration, and
like
nothing's
a squirt
happened.
gun at a flamethrower.
Yeah, right, squirt gun. Yeah. So I literally frantically disconnected the hose, because you had to use a regular house hose, from the truck, the toy,
As
and
you
then
do.
sprayed it with the hose. And of course, I had to run back, turn the hose on full, come back, and use my thumb over the end of the hose to really spray. And it still wasn't putting it out. So I had the pool next to me. And so I went and got the bucket, which took time. And I started taking buckets of water out of the pool and throwing them at this fire. And by the time I put it out, okay, we had, in that house, we had about a quarter acre of land. Literally, almost all of the backyard was black.
Jesus.
And the trees were burned up the sides because I had a fire to put out with my Tonka truck. And I just sort of put my truck away and like thought to myself, all right, no one will notice.
Yeah, sure.
I went in the house, and when my father came home, we said, oh, really hot. I'm going to go out in the pool. And I said, oh, Dad, don't go out in the pool. Read me a book or something. Or can you work on my train set with me? And that worked for a little while, but then he goes, yeah, I really got to go out in the pool. And I was like, oh, I am so dead. He goes out the back, and the door slams, and I hear nothing. I didn't hear him getting on the ladder to go in the water. I heard nothing. Why? Well, you know why. He was staring at his black yard, going, what the poop is going on? And he goes, he called my mother's name was Mildred, and he used to call her Mill. He'd say,
Son,
Mill,
good job. I don't have to mow this summer.
Mill, you get that boy out here right now. And she goes, what happened?
You should have came out and just was like, only you can prevent forest fires.
Hey, I stopped that guy from burning down our house, Dad.
Yeah, right. Say, Dad, I'm a hero.
Yeah, I was trying to.
You don't see the size of the fire I battled this afternoon.
Oh, man. I'll tell you
Hey,
this.
Fum, it's not us either. We're in the green across the board, man. I don't see no buffering, no skipping, no jumpy at all. So
see 33% CPU and 23 frames per second.
Yeah, we're good. We're good to go. So it has to be at your end.
Yeah, and it's right. Yeah, my black yard, instead of backyard. Yeah, exactly right. And when my mother went to look at that, she looks out in the yard, and my mother had this way. If something was really bad, she'd go,
like the long inhale.
That's Marky, what did you do?
That's the pre-beating of your life.
Meanwhile, you're out there with matches, like, look what I can do.
That was the pre-beating of your life, noise. And my father chased me all over that house to tan my hide, and when the belt came off, it was serious.
Look, Mommy, I made calcium.
Well, he needed range. You know, he had to use range because I was kind of quick. So he'd have to use the belt for extra range. And man, he caught me a few times in the back of the thigh with that belt.
Oh, Jesus.
Man, that was painful.
You know what? But after this story, I kind of think he deserved it.
Yeah, you know, the worst part is that when he hit me, you know, I probably should have just taken my lumps and just left it. But
oh, none of us can do that, especially if you're a boy.
No.
Oh, we're going for it.
I had to yell out, "That didn't hurt." It's like, as I was saying it, it was almost like slow motion. That didn't hurt. You know, it's like, oh no. I'm thinking, what are you doing? You're about to get beat worse.
Or it hits you somewhere it wasn't supposed to. That hurts 10 times worse than where it was supposed to.
That's correct. You know, and it was like, oh. And he said that hurt, and you know, I should have said yes. But I said, no.
You can't hurt me.
Back, he slapped me again. Oh, and now, I mean, it was, I saw stars. It hurt so bad. And he says, did that hurt? And I go, that hurt. I knew better finally the third time. I was like an idiot.
I'm trying to figure out why people are saying it's glitchy. I don't see it. Like, I'm steady across the board.
I see that. You know, I
even see it on the YouTube feed. I'm watching the YouTube feed. It's...
Yeah.
See, my biggest thing to get rid of glitches is that's pretty much why I keep that scroll at the bottom. The scroll at the bottom, if I see it, you know, staggering a little bit, then I know the feed's weird. But it's going fine.
Yeah.
So I'm not sure. I'm not sure what's going on.
Yep.
As I said, we're green across the board. Everything looks good.
Yeah. Yep.
All the signals are good.
Yeah.
So I don't know. Maybe it'll get better with time. I'm not sure.
Maybe
if you've been watching since the beginning, maybe F5.
Maybe maybe my stories are making it, you know, get glitchy or something.
Yeah, I mean, hopefully these clouds move out. You know,
yeah,
and they usually do because the moon still has to rise a little bit. So you know, this is east, and we've been having we get some pretty good pockets of clear air here, but they are coming in off of the Atlantic. And last I saw the radar, that the bulk of the moisture was center state, moving up northwest towards Tampa. So, but the daytime showers were dying out. So, yeah. But right now, it's really. I mean, when the clouds come, it's going to really mess with the resolution and stuff because it can't keep focus. The clouds mess up the focusing of the telescope. So,
and I will say this, with Jupiter in particular, sometimes, and this is something I've noticed, and I've seen this on 20-inch refractors, large. I mean, it was a 30-foot long refractor that I was actually in charge of at the observatory when I was doing my parallax research.
Right.
Okay. I sometimes would take it and point it at other things like Jupiter, and I looked at Jupiter one time, and it was like I counted 19 cloud bands without even missing a beat. It was just stunning, and you could look right at them and see it's just beautiful. And then I pointed it at Mars when it was around, and Mars ever only looks like an orange ball, unless it's really
not to us.
I know that's where I'm going here. Unless you have really good seeing, and Mars is not so much, doesn't require so much of a bigger diameter telescope, but just a good quality lens system. You could actually see details on Mars with a 2.4-inch refractor if it was a good quality one.
Don't mind me with the banging. I'm trying to get the wire to work.
That's okay.
There we go.
And you had the other night, you had Mars just with in spectacular fashion,
yeah, we were getting definition in the center, and we were getting the caps.
Yeah, see, I did that yesterday. I mean, and when, like I said, when the camera was just not cooperating, I just decided to quell my anger by taking some shots of Mars, and it looked really, really nice. And I could see I could see one polar cap, I could see some central detail, and I could have actually gone in. And I have a dynamic Mars map, so I can actually see what's right there now, and I could have figured out what I was looking at, but I just preferred to look at it and see it. So what I did was I actually took a 30-second set of video at 30 frames per second of Mars. And what you can do, and this is for all of you listening and all of you in the chat, there is a product out there with which you can actually create a set of images from the video, and this product will rank them in order of highest quality to lowest, and that product is called PIP, PIPP. That's Planetary Image Preprocessor. All right. And PIP is something you could then get your organized images. Then you use another product called, a stacker product, a product to stack the images, Registax, Deep Sky Stacker, and you could stack all those images, all the best ones together, and get a final image. So that will give you a higher quality image. I've done it for images like the moon here. I've done a 30-second video of the moon. Now I'm doing this at 4K, which is a high resolution video-wise. And when you're doing a video of the moon, you then get, in each frame, you get this image of the moon. Now, a frame at 30 frames per second, is 1/30th of a second exposure, basically. And when you're doing that, those frames in a telescope that's stable will be nicely, sharply focused. Now, if you add them together, you layer them on top of each other, the first thought is, it's so bright, won't it just blow it out to a big white thing? Well, yes, if it didn't correct for that. But it does correct for that. They all do. So you actually eliminate that, and what it does is it improves the very fragile lines of a crater, the edge of a crater that are very faint. They get gradually more distinct when you stack more images of that little faint line on top of them, on top of itself. And by doing that, you actually pull out what we call the signal, that is what you want, and you kind of suppress what's called the noise, that is the stuff you don't want. And the noise is, for instance, the turbulence in the atmosphere that we see sometimes on the moon here, where you see it shimmering a little. Well, that would not be considered a good frame. So we would actually get a better quality frame, or a set of better quality frames. And I would routinely stack over 1,600 moon frames.
Oh my!
Right, video and get a final image of the moon. And because I'm taking them in color, I can actually get a rendering of the moon in color. As well. And the moon has a tremendous scope and range of color on it. It has browns, it actually has reds, it has white, of course, and there is, of course, gray. But the moon has primarily got a brownish tone to it, which is something people don't think about because their eye can only see this gray. But there's really a very subtle brown color to the moon, and you can see it in the Maria.
I just tried to bring it out on the screen, but I think Paul's running black and white right now, so I can't bring the color out.
Yeah, I was going to ask you if you could do that, actually, because but I can tell that he's doing black and white because I can't see any of the subtle tones that I normally would see.
Right.
Just text him. Tell him to do color.
No, I ain't going to interrupt him.
Okay. That's fine.
Yep. We will, though. He usually does switch to color, especially when it's the full moon.
Hey, Wild. Wild saying hi to her.
Let me run down the chat list here. Give shout-outs to the people that are in the chat and chatting along with us. I'm just going to go through the participant list. I'm not actually going to go through the whole chat. But I have about 8 people right now that are in the chat room. We got Fum and James May and Jed and Jenny and John Glenn and Victor and Vicky, Wild Vicky, are who have participants now. I do see that Jed is in here. Anybody else that I'm missing? John Glenn, Aaron V, D Smith, James Meade, Q questions. Who?
Wild.
Yeah, Vicky. Wild Vicky.
Oh, is that what that is? Okay.
Yeah. And Genghis was here. Scott Meyer, Tron Man. Welcome everybody. And if you want to, if you want shout outs in the chat and whatnot, and Ted shows up. And Doughboy. But yeah, if you want shout outs and stuff, just make sure you're participating in the chat. And of course, welcome to everybody that's also just listening in or watching that isn't in the chat. We appreciate you as well. If there happens to be any objects that cross the moon, any anomalies, satellites, etc., we do use the clock on the bottom left of the screen to timestamp it. That works way better because the YouTube time is constantly changing as we are broadcasting. So that it doesn't work to mark it on YouTube. So you have to use the atomic clock on the left-hand side down there. And you can timestamp it right into the chat box. And I write those down and then I look at them the next day just to be sure. So that's how that works. For anybody that doesn't know. And welcome to GM too. I see it just popped in. I have a question about the object from the other night. If the surface of the moon was in focus, the surface moon was in focus, and the object was much closer to us than the moon, would the object be in focus? No. Well, depends.
Do you want to answer it? Or you want me to answer that?
Yeah, you can answer it. You'll do a lot more.
You've seen your cameras when you actually focus on the moon, for instance. Okay. If a jet flies through the field, it may or may not be in focus. It depends on the focal length of that lens. And sometimes you can actually have a deep focal plane. So you might have something that could be, 1,000 feet away all the way out to the moon can be in focus. Oh, something just went by just now. It looked like a bird. And so watch for it. It's like zone 1, 2, 3, 4, 5 down through the center, just past Tycho crater, which is in the middle.
Definitely a bird.
Yeah. Well, anyway, so you can have something that's in focus. Now, the question is, if things are in focus, does that mean that they're going to be fully sharp? Well, no, not necessarily. Even if they're in focus, they might not have that sharpness, and that could be due to the speed they're traveling across, the frame rate of the camera that's being used at the moment. A lot of things can go into whether something looks like it's in focus or not. So to answer the question, yes, you can have something in focus that's in the Earth's atmosphere transiting the moon. In fact, the focus tends to look sharper on objects in our atmosphere than not. So, it's something you can just store as food for thought. And I know that it's actually when we see objects cross the moon, it's always a very heightened, sense of perception for us. We want to make sure we understand what's crossing, and I know that many satellites cross the moon. It's a half a degree across, and it's traveling roughly on our celestial equator, which is our equator extended out into space. So we tend to we tend to expect that satellites will cross between us and the moon because the geosynchronous satellites will be out there at times when the moon crosses that celestial equator. And so that being the case, we often expect to see transiting objects in front of the moon, and many times they are satellites. Okay, and they're typically will show us little black dots, and what we can do with those little black dots is, and then that size of the black dot really doesn't give us the information that you may think it does. It doesn't tell us the size of the object. Okay, not unless it's closer to us, not unless it's in our atmosphere. If it's a satellite, then the object can look artificially larger than it is. Again, part of the video artifacting that can occur. But we can tell by the speed at which it crosses the face of the moon. We can tell a lot of things. For instance, we could tell how high an orbit it's in. So if it's a satellite, we can calculate its orbital speed, and then that could tell us how far out it is and what its orbital radius is. And so if it's something that's let's say a booster that helped boost something to geosynchronous orbit, which is over 22,000 miles out, well, we might have a booster that's coming to the field, and maybe it's 12,000 miles out or 14,000 miles out, and that's something that is just the booster that got this thing out to that area. And now, of course, the booster's in this dead orbit forever, just going around the Earth.
And our resident future astronaut has arrived.
Foxy is here.
Hello
there.
Here.
How's it going?
Foxy, we are live with Mark D'Antonio. He is a professional astronomer. You can see him on NASA's Unexplained Files and One on Earth, amongst a whole bunch of other stuff. And, of course, you can hear his show, SkyTour Radio, on Sunday nights at 9 p.m. on KGRAradio.com.
I'll send you that $5 tomorrow.
You're welcome.
Yeah. Thank you. That was kind.
I did that on Billstream the other night when you were there.
Oh, yeah?
Like after you hung up. Because he was like doing it. I was like, you know what? I have a rundown that I usually do for Mark. And I did it over on his stream.
Well, that's cool.
It's like memorized by now.
Yeah.
Yeah, you are kind of all over the place lately, aren't you?
I guess. But, I'm okay. I think that, here's how I look at it. Knowledge is not going to wait for anybody, okay? It's not going to, it's not something that people are just going to get imbued with unless they hear it and then they do some research. I'm a constant researcher. I'm always looking for new information. I'm always looking to open my mind and see better things in other ways, which is why I get in trouble with other people in astronomy, because, you know, I am an astronomer, but I'm also a speculator. I'm willing to talk about the possibilities. You know, yeah. I got in trouble with people for suggesting that our galaxy was a populated universe, and the populated universe is the name of my book. You know, it's the populated universe. I wrote it because I believe the universe is populated. We have other life out there, I believe, and I'm not using a "I want to believe" thing, or I'm not saying, you know, any other reasons for why I believe other than scientific. There's scientific reasons I believe in this, you know. Yeah. And using science alone is enough to give us a clue as to what may be out there. I'm not saying it is, but look, we got here. And, you know, when I do my talks, you know, like as we already said, I got the Devil's Tower UFO Rendezvous coming up September 13, 14, 15 out in Hewlett, Wyoming, where you'll be a month later. And there, you know, I'm going to do a talk like I've done elsewhere. I did one in Ozark, Arkansas for 600 to 800 people in the audience. And I put the entire history of the Earth on a roll of toilet paper. And I unrolled it. I went out in the audience and I unrolled it, had them helping me, holding it. And we went through milestones of development on the Earth, or, you know, as well as the, you know, talking about the things that happened on the Earth, like the major extinction events. This planet has been bombarded. We lost 96% of the life forms on this planet at one point. That was in the Permian period over 200 million years ago. And somehow, you know, life found a way. Now, what happened was, when the Permian extinction event occurred, you know, we had mammals at that point, and reptiles that were like mammals, that were on their way to being mammalian creatures. And when that happened, when the Permian extinction hit, the mammals, they basically had to retreat, and it literally, that Permian extinction paved the way for the larger creatures, the dinosaurs that came later. And then when the Jurassic extinction occurred 65 million years ago, okay, there have been like 5, but when the Jurassic one occurred, the most recent one, the major extinction, then the large reptiles died later. And then when the Jurassic killed off by that, and that left a hole for the mammals to reemerge and come forward again, and that was us. See? So had that not occurred, then perhaps the intelligence that developed on Earth, if at all, would have been different. Maybe we'd look different. Maybe we would have more reptilian features if we even approached intelligence. You know? Yep. You know, we have an opposable thumb and so forth. And the other thing that, you know, we look at the Earth and the life, and this is another thing I talk about, and I've been doing this all over the country. I've been telling this to people because this is important. When you look at life forms and how they develop, all the life forms on this planet, you know, the more, you know, advanced life forms, let's say beyond the multicellulars, but when you have life forms that actually have, you know, say vertebrate life forms, have a spinal cord, okay, and bones, all right? Vertebrates on this planet, they all have something, and the invertebrates have something going for them that is amazing, and it's either bilateral symmetry or radial symmetry. And there's also pentagonal symmetry where it's 5, like starfish. But see, this symmetry is something that the universe provided a template for, you know, because of the nature of the way the building blocks of life were delivered to the planet and the way the planet itself made the building blocks of life. This planet did all that stuff. All right, and meteors and comets delivered this stuff to us, these amino acids. And somehow within all that, the template for symmetric life forms arises. We're not symmetrical on the inside, but we are in some cases, but not fully. We have one intestine. We only have, you know, one heart. Okay, but you know, when we look at the way the life forms developed here, everything is symmetric. So that means, without any help, the universe generated a template for creating life forms that were symmetric on this planet. And if that's the case, it means that it probably happened elsewhere. Why? Because it was natural for life forms to develop that way here. All right? Through all the twists and turns, life developed. All these billions of different species, actually, on the planet, developed with this symmetry. that means that I expect that we'll find symmetry at other planets.
Let's
I'm
hope.
I'm not looking for life forms. And like I've said before, we aren't going to see pogo stick cows in one leg, boing, boing, moo, boing.
But that
moo.
would be cool if we did.
It would be cool. It'd be very cool.
Actually, let me bring it back to the moon real quick.
Yeah.
Do
Not
you think people? I mean, we've talked about this before a little bit. How I don't think people really grasp how big the moon is, and this kind of relates into Foxy's question about crater sizes.
Yep.
Because, like, when you look at the moon and you see craters, even with the big scopes that we're using here, you look down the crater, but like people usually see the complex craters, which are the craters that have the peaks in the middle of them, and they go, "Wow, that's a giant tower," not realizing how big that actual peak is,
Or how spread out it is.
exactly. So,
Yeah.
just to give us a rundown of how big some of these complex craters actually are, and maybe if you could explain pretty much almost to scale, like how far, like when we really zoom in on a crater, how much area we're actually seeing. You know what I mean?
I'm trying to know what you mean here.
Like,
Well,
just
okay.
give some.
Let's start with something simple, okay?
Yeah.
You were talking about Aristarchus crater before. Now, unfortunately, we can't see Aristarchus right now in the view, but right now it's sort of just left of center, kind of almost seeing it, but not right this second. But for instance, Aristarchus crater. When we look at that crater, that's a crater, for instance, that's I'm trying to remember how big it is. Is it 35? Is it 35 miles across? Shoot, I drew a blank for some reason.
brain fart.
I know, exactly so. It's like, uh-oh, what happened? No, it's 25 miles across. Sorry, yeah, 25 miles across. That's what it was. I don't know why I didn't think I knew that. But, okay, if you look at Aristarchus, Aristarchus is an example of a crater, and it's just there hanging at the top there on the left. You can't just... It's very bright white. It's very shiny because there's a white material that was blasted out of the crater and sent eastward, toward the east, as you're looking at it from here, and that material was like gouged out, and then the impactor, the thing that struck, was vaporized, and it doesn't matter the angle at which it hits. The angle at which it hits will cause the stuff that gets ejected from the crater to go off at a different angle. But the craters are always circular, and that has to do with the way the energy is distributed at the moment of impact. All right? I'm not going to go into that any more than that, but just say Aristarchus, for instance, is a crater that actually has some interesting complexity because when you look around the edges of Aristarchus, it has these rings around the edge. It has these rings around the edge of it, and that's due to the nature of the impact and so forth. Now, another one that's famous is Copernicus crater, and Copernicus crater is a big crater that's it's right there just below the word Aristarchus, actually, on the screen. And when we look at Copernicus, we're looking at a crater that's actually a complex crater. And what's that? Well, a complex crater like Copernicus, and it's 93 kilometers across, all right, is a crater where when something hits the moon that's beyond a certain size, something happens to the surface. It goes through a process that causes shock waves to be sent out from the center, more than a simple crater, which is like a bowl shape. And those shock waves cause really interesting effects. Among them, these terraced rings around the outside edges of the crater that come down into the crater, and then a central peak. Now, you wouldn't be entirely wrong to think of that central peak as like a frozen splash. If you saw a drop of water, when you drop something into water, that's the bloop, where the water in the middle comes back up for a split second and goes back down. Well, if you think about it, that's the bloop of the complex crater in effect. And so we're seeing what happens when material comes back to the center and kind of lifts a little in the middle during the impact. And this all happens within a few seconds of the impact. And then, of course, it goes back to being, acting like a solid from acting like a liquid. And because that happens when you hit something with enough energy like this, the vibration and the impact will cause it to liquefy, in effect, not melt, but just sort of run like a liquid. You can simulate that. There's a special table you can make called a shaking table, which is made of like sand. You put sand in it, and it's a bowl basically, and it's got sand in it. And you put a model building on it. If you set the sand on a shaking table, and then you set the vibration at a certain frequency, you'll watch this building sink down in the sand like it's in water. All right, and that's because you've done something called liquefaction to the sand, and it's a process by which the vibration causes enough of the sand particles to move against each other such that they act more like a liquid than the solid that they are. And so things will sink, and then you shut off the table, and now you've got this building embedded in this heavy-duty sand. Well, now you look at a crater like Copernicus crater right in the middle of the moon when it's a full moon, and you can see that the impact was a pretty hefty impact because it actually created these gigantic patterns of rays coming out from, and we call those rays, that are coming out from the crater. And that crater impact was a high enough energy that these rays went out hundreds of miles.
But size-wise, like the actual size of the actual crater, most of them that we can see with the telescope, you're looking anywhere from 35 to 160, 70 miles, some of them.
Oh, yeah.
Miles.
Yeah, and like Copernicus is, 93 kilometers in size. So it's, it's actually a pretty good-sized crater.
But when you see these peaks come up and people say, "Oh, there's a tower in the middle of that crater," well, that tower must be, 5, 6, 7 miles wide and 13 miles high. Yeah, because they don't really just appreciate how big that area is that we're looking at just because we're zoomed in on it. You know what I mean?
No, they don't. They don't understand, and that's okay, because that's people generally don't in many ways understand what's going on.
Which is the reason a lot of the flat earthers too, because the flat earthers just do not realize how big the Earth is. Like they're like, oh yes, Earth is a blue ball floating in space. You see pictures of it, but they don't actually get the scale of how big this planet actually is.
Yeah, you could tell people that the moon is 2,159 miles in diameter. Well, guess what? Human beings can't comprehend 1,000 of anything. Never mind 2,000. Okay. When the Titanic sunk, they had to actually put over 1,000 people on the dock at where the Titanic had left from to show people what 1,000 people dying looked like. Yeah. Because to say 1,000 people died or more than 1,000 people, it didn't have any impact. But show 1,000 people, wow, that's a lot of people. See, you strike a different part of the brain, and that's exactly why we do this. When we say, and I like to use analogies because that actually helps us. I like to do, especially when it comes to big numbers. I like to do the stadium reference because a lot of people have been to stadiums and know what they look like. Like, we have 24,000 subscribers. Yeah,
that is, enough to overfill most stadium venues, like indoor. What do you call them? Arenas.
Yep.
Most arenas only seat 14,000, 15,000 people.
Wow.
So if every one of our subscribers came, we wouldn't have seats for all of them in these arenas. Now imagine the people with 100,000 subscribers and millions of subscribers. Some people have subscribers that are more than the populations of cities like Philadelphia or Tampa.
Yeah,
it's really like you got to put it into scale. To understand, and people have a hard time understanding scale measures when it comes to the moon and Earth.
Yeah, no, that's okay. People don't get that.
And most people see Jupiter and Saturn as these giant planets, but most people don't know that you could fit every other planet in between the Earth and the moon.
That's right. And that's because they don't understand the true distance that the moon is from the Earth. If you saw that true distance, you'd say, oh, why? It looks so big in our sky. Well, it is 2,000 miles across. And at 240,000 miles on average, it will look, about half a degree in our sky, and it's just very difficult for people to understand that. And then they would think, well, how come there's not an eclipse every time the moon is a new moon? Well, when you know the distance of the moon and you understand the angular tilt of the lunar axis, the slight angular tilt, and the way that the moon orbits the Earth, you can understand why it's rare for the moon to cross between the sun and the Earth. It's hard to get that shadow to line up. You know, hard, and it's not that easy. Now, there's a question here in chat. Is the moon a hologram? Nope. The moon is a solid body, Gerardo. I can tell you that for sure, as I don't believe anything else. I made holograms, actually. I used to teach classes on making holograms, and I would actually bring entire classes through the process of making, taking a chessboard and making a hologram of the pieces, so that when they actually looked at this film that we made, you would actually see the pieces moving in front and behind each other because of the fact that we're looking at this holographic image. And it's a rather fundamental process that has to do with an interference pattern. When you look at film that has a hologram on it, you can't see an image unless you pass a laser back through it. That's the way you'll see these. Now, there are white light holograms as well, but you don't see white light holograms in any kind of color other than these rainbow prismatic effects sometimes. You don't see perfect color rendering with a color hologram. There's no way to put a holographic image of the moon up there and have it do the things it's doing, have things pass in front of it, and do that. And while we're at it, I'd like to address the lunar wave. I mean, there are people that talked about seeing this lunar wave. You remember these guys, right, Keith? You've seen them.
Yeah.
And
the old famous lunar wave.
Right. You know, it's sort of like this little, you see across the face of the moon, you see this little disruption to the image, and it looks like, oh, look, we've caught the hologram. No, actually, you caught the remaining air from a passing jet that heated the air, and you're watching the hot and cold air, the relatively hot and cold air to each other, of the contrail of the jet, and it may not be a contrail at that point. It might just be warm air. And as it passes across the face of the moon, which it does all the time when jets pass in front of the moon, or pass by the moon, they don't even have to pass in front. That contrail, that warm air exhaust from behind the jet just has to pass, because the air is moving. Because that's another thing people don't get, is that the air masses on the planet are moving as a whole.
Yeah, and also that a jet's not the only thing that can cause that disturbance either. You know, we've had it where, you know, even the jet stream can cause that to happen. Outflows of the jet stream. You got, and I even talked to one astronomer who said that micrometeorites or meteorites right off the moon that maybe you don't even see could cause that to turn through the atmosphere.
That's true, actually, because meteorites also heat up the atmosphere as well. And we do get hit by a lot of meteoritic dust. I mean, you can, if you lay a sheet out in your backyard, out on an area that has a fairly clear sky, and I mean clear pollutant-wise, you can come out in the morning with a magnet and pick off the little meteoroids that came in during the night. We collect millions of tons of this stuff annually on the planet. So the planet's growing in size based on that. So to anyone asking the question before you ask, yes, the Earth's gravitational field is increasing over time because of the influx of this meteoritic dust and particles. All right. However, we're also losing stuff to outer space all the time as well through the sun breaking down particles and molecules in the upper atmosphere, and then some of them getting away. Luckily for us, a lot of that stuff is replenished over time, so it comes back through other processes. But we are losing mass as well as gaining mass. You know, so it's pretty cool. Yeah. We have a very, very complex, very dynamic planet. I mean, it's absolutely crazy.
I will give everybody a warning right now. There is some storms that blew up to the east of Paul. That means they're heading his way. But he thinks the first one is going to go to his north, and the other one might go to his south. But he did put the big scope away just for now, in case these do come his way. He can pull the small scope in real quick for any showers that pass, and he'll bring them back out then. Just if you know the screen goes black real quick, you know a shower came in out of nowhere. Just so you guys know.
Well,
it was Jed. Jed, on screen, you'll see in the bottom left corner how we view the moon. The red spot is the spot that we always see. The moon does rotate. It just takes 27 days to do it, the same length it takes for the moon to go around us. And that's why. we only see the one side.
That's a really good thing that you put up there, and I think that it's important for people to understand why that situation has occurred. See, our planet and the moon ended up locked in a little gravitational tug-of-war early on. The moon used to be a lot closer to the Earth, right? And the Earth's day used to be a lot shorter. And our day is growing longer as the moon spirals away from us slowly. And as it spirals away from us slowly, we are also, we're losing what's called angular momentum. We're slowing down a little bit. And the moon is getting a little farther by 2 centimeters a year. Now, you may ask, and I can imagine you'll ask, well, how long before the moon is not orbitally, gravitationally bound anymore to our planet? And the answer to that is, well, frankly, it's going to always be gravitationally bound to our planet for the foreseeable future for us, because we are in a solar system where the star is going to last about another 5 billion years, and it's going to take way longer than that for the moon to spiral away. So we'll be safe. We'll always have a moon, which is the bane of astronomers. But for guys, like me that are into astronomy and planetary science, the moon is a fascinating place. Not now when it's full or almost, because then there's no contrast. We can't see anything. There's no contrast on the moon. But I appreciate the streams on the moon. So I would actually say that when we look at the moon and we talk about how far away it is now and how it got there, we have to understand that when the moon was closer to us, it was locked to us as well. All right, and the reason is because of the differential gravitational pull on the moon and the Earth, and that it's called tidal locking. Now, the moon is not round. Many people think it's round. You look at the image and say, hey, the moon's round. And even when it's full, it looks round. But what's different about the moon is that the center of gravity, the center of mass on the moon, is actually tipped toward the rear side of the moon, the one that we don't see. So it's sort of oblate. It's oblong mass-wise. And so this means that one side of the moon over the other is favored gravitationally. So that makes tidal locking even easier. Now, you might think, well, shouldn't the heavier side of the moon, the more massive side, be toward us? And, yes, possibly. But because this was set up early on in our history, the moon ended up in the position it's in. And you'll notice that on this side of the moon, we have all these darker gray maria, the lava seas that we see on the moon. On the far side, there's almost none. Very, very different, markedly different terrain and landscape on the backside versus here. And the reason for that has to do with the formation. When it was early in our formation, the moon was semi-molten, the Earth was semi-molten, and we had a lot of heat generated here. And heat is infrared energy, down in the red end of the spectrum. It's electromagnetic energy, it's radiation, and that radiated out toward the moon. And that radiation has a force associated with it, a pressure, you might say, radiation pressure. And as impacts hit the moon, the moon impacts would throw up this stuff into the area around the craters on the near side and the far side. But on the near side, the radiation pressure from the cooling Earth would, and this is a theory that has been put forth actually, would generally push that material away from the Earth. So what's that mean? It means that it would tend to make it pile up on the other side of the moon. All right? And that's why the far side of the moon is actually thicker. The crust is much thicker than the near side. So we don't see maria on it because rocks that hit the moon on the far side would need a tremendously larger amount of energy to actually dig down deep enough to bring up this upwelling of magma and to form these lava seas. We don't have that on the far side because they don't hit with that force that's high enough to go deep enough to bring up the molten part of the moon. On this side, the crust was a lot thinner. So when these impacts occurred, they brought up lava, and as you can see, they flooded vast areas, hundreds of miles, with this lava that came boiling out of the inside of the moon, like that. So that's one of the theories that is in place for why we have Maria on the near side and not the far side. So that's a really interesting process, and I read the scientific paper on it, and I've kind of boiled it down to a little bit of a I should say a little bit of a summarization here for you, so you see kind of what that's all about. But you know, Plato crater, for instance, a 60-mile diameter crater right near the top that we just saw a moment ago. Okay, and it's coming into view now. Plato is about 60 miles across, and you'll notice it looks like it's a flat-bottom crater. Well, what does that mean? I mean, was it always a flat-bottom crater? And no, the answer is no. When it was first made, what was called the transient crater was actually a depression. So it had a bowl shape to it. All right, probably a complex crater in the making. However, when lava infilled from the impact, because that's the near side, when lava impacted and I'm sorry, when the meteor impacted and lava started coming out, it flooded the inside of the crater. And of course, it sought its own level, and that level was flat, and that's why it kind of looks like that. Now, there are some differences if you actually cruise through the central plane of Plato, you know, by going through any kind of program like the Lunar Reconnaissance Orbiter program. There's a 3D moon section of the Lunar Reconnaissance Orbiter quick map, which again we're going to do as a Sky Tour live stream eventually, and you know, I'll show you that again. And that is it shows you the terrain differences and how the terrain looks, and you can literally cruise over the surface and see it right from that perspective. It's just beautiful. And I'll take a moment to just mention, if you look at the Lunar Reconnaissance Orbiter quick map, that's all one word, quick map, you will be able to cruise down to see the moon at literally a half meter per pixel in resolution, meaning you can see the lunar landers, you can see the tracks from the rovers, and you can prove to all the moon conspiracists that we're there because there it is right in front of you. And then, of course, they say what they always say, well, NASA's always printing fake pictures. Right. Everyone, even the Russians, every single nation, the Japanese, the Chinese, they've all produced these fake pictures because they're all keeping the secret. And the answer is, why? To what end? If the Earth was actually really flat, then we would have just grown up with a flat Earth. We would have evolved into knowing it was a flat Earth.
And by the way, I brought the color out a little bit. I overdid a little bit just so you could see where the color differentials are. Just to give you an idea. The browns and the grays and whatnot.
It's really beautiful.
The moon has color.
Yeah.
We usually do it in black and white because, number one, black and white takes away from a lot of chromatic aberration. So you don't get that distracting, you know, purple, blue, green, you know,
on the sharp
rings around on the sharp edges of stuff. So that's why most astronomers use black and white.
Yep.
Just to take that out of there.
It's just that material, yeah.
Right. But that's a good kind of it's an overdone representation of the colors. I kind of made them come out a little bit more than they actually do, just to show you where they're actually at.
Yep. That's really nice.
So if I did actually lighten it up to real color, that was a bird probably. It's more like this. Well, except for the edge of the moon. Edge of the moon is still a little brown, but
yeah,
you know, that's more of a.
Maybe want to lower the brightness a little on that because it's kind of
not really.
Really
it's full. Yeah, you can still see the blues and the browns and the.
Yeah, no, I see what you mean.
Paul said as soon as he feels safe that the storms are past, he'll put the 11 back out.
Yeah.
So, yeah. Gotta love Florida. Gotta love Florida weather.
Ted, I got to answer that question. Ted just says, an astronaut did paintings that included all the color he saw on the moon, not just gray. You're absolutely right. And that astronaut was Alan Bean.
Alan Bean.
And, I actually met and had dinner with Alan. And unfortunately, I think he passed away. And I got one of his paintings, actually, that he did. And he and I actually painted the same thing from my perspective as just a science guy and his perspective as an astronaut on the moon. He walked up to me, and he looked at me, and he goes, "More color, Mark, more color." And I was like, "Really? What do you mean?" And he was captain. He retired as a captain. So, Captain Bean, what do you mean? And we went out to dinner and sat and talked, and he said, "You know, there is a lot of color on the moon. That's the thing that people don't realize. You know, they see the gray blob from here, but you know, once you're there, you see there's so many. It's a microcosm of many different colors. You know, there was red soil, for crying out loud, in one place that we had, and then you know, white soil and browns, and you know, I think even some other colors like purples and stuff. And I said, seriously? No, that wasn't just something because of the gold sun visor on the helmet? He goes, no, I don't think so. He goes, we actually saw these real colors. It was amazing. And that was a real great night. I got to talk with him. He was talking at a science center where I worked, and when I started talking to him and I started showing him my paintings, he was talking at a science center where I worked, and
I'm not sure why his microphone keeps cutting out, but it's cutting out on us. And I'm not sure where he disappeared to. I don't even see his feed lighting up. Maybe he has a bad battery on this microphone. Mark, we'll wait for you to fix whatever your issue is there with your microphone. But and I'm pretty sure Mark will be back. But yeah, once again, right there I have the color overdone on the moon, just so you can see the differences. And let me just make sure it's nothing on my end. Doesn't seem like it, no. And I think I'm correct in saying that you all can still hear me, but probably not Mark. Correct? Here comes a cloud. So yeah, maybe he had a bad battery or something. Or maybe he's still talking and doesn't even realize we can't hear him. No idea. He'll eventually realize it. But yeah, once again, Paul pulled in the 11. Because of the threat, a little rain shower was creeping. And he did it as a just in case measure. But once these disappear, then he'll bring it back out. So I'll tell you what, I'm gonna turn up the music a little bit and see if I can get help Mark deal with the issue with sound, and then we'll be back on in a couple minutes. So we'll be back, guys. Let's bring us back into the fold.
Ball Busta.
Ball buster. Ball buster.
He wrote, I wrote, someone wasn't tout.
Tout. Tout. Yeah, the main thing we have to say, ball buster, is that you have to match observation as well, man. And observation is exactly what we showed you, but his or hers, if you can prove it that it works a different way, we're all eyes and ears.
Yeah, but it's going to be a hard slog because we have actually a couple hundred years of physics behind us to talk about the way this operates this way. But I understand. People have their own thoughts and they have to ease into science because sometimes science violates what you see with your eyes. I'll give you an example. And sorry I dropped before, but if Amanda Curran, my co-host on SkyTour Livestream and on SkyTour Radio, was here, she'd say, "I love you, NSA," but it wasn't that. It was my internet just dropped. When we look at the way things work, you think about this. If you really want to stretch your brain, some years ago, we discovered something called quantum entanglement. Now, this is something that really throws physicists for a loop, and the reason is because it's something that shouldn't happen, but it does. I mean, we don't know everything, and that's great. I love learning new things. When they had a number of atoms of a substance in say, laboratory A, and then they split apart some of the atoms and took those atoms to laboratory B. In laboratory A, they changed the characteristics of some of the electrons in the atomic structure of the atoms of that material that was in lab A. And in particular, they changed the electron spin from like down to up or up to down. It's a characteristic of the atoms. And nothing should have happened in that. It should have just changed those atoms. But in laboratory B, totally and wholly separate and distinct from laboratory A, laboratory B's electrons also changed spin at the same time. You see that? That's something that tells you that there was a connection at a quantum level, and they ended up saying, well, they're entangled in some way, so we're going to call it quantum entanglement. And I think that there's something to that at a more higher level. I think that perhaps that's responsible for things like people thinking they have clairvoyance or ESP. I was just thinking about you, and I haven't talked to you for 10 years, and boom, you called as soon as I was thinking of you. I don't think that's mysterious anymore. I don't think it's their clairvoyant. I think they actually have a entanglement, and I call it brainular, like the brain. It's something in the brain level. So I think there's some kind of entanglement going on between the atoms that make up the brain, and maybe it's not even at the atomic level at that point. I don't know, but anyway, that's a neat thing that is something that is worth investigating. I think on Sky Tour Radio we're going to try and do an entire show on quantum entanglement at some point. And then
is there any plans for your show to go to 2 hours anytime soon?
Well, see, the person who comes after me on the radio station, she has a fairly solid audience, and the guy that comes before me, Commander Cobra, great friend, okay, he has a solid audience, and the audiences have an expectation of the time slots. So I would have to move to a different day to get a 2-hour show. And for my
what if you took a half hour from each of them?
That's kind of interesting. I wouldn't want to have anybody move on my account, and I'm a newcomer to this, you know. But I'll tell you this, you know, our show on kgraradio.com, for its time slot on Sunday nights, it ranks between 3 and 4 in the nation, you know, for that time slot. And this month and last month, it was one of the top 2 or 3 shows downloaded from the radio station. So I thought that's pretty cool. So we actually have quite a bit of a following out there, you know, even if no one's saying it. I think the good part, see, this tells me something. It tells me that, yes, I talk a lot. Okay, but it also tells me that there are people out there that are hungry for science. And they know that I believe in UFOs, and they know that I know that UFOs are nothing more than an extraterrestrial craft that made it here across the void. I do. I believe that because the science says that it's not so out of the question for me. I'm not a hardcore science guy to the point where I say I have to see the evidence before I'll actually believe it. I actually try to hypothesize the existence and then try to prove it. You know, I kind of come at it from the other way. And I think that's fair. I think that's a fair thing to do, frankly. You know, I think that I think that's actually pretty interesting. You know,
Right.
and then there's a question I think that Ted asked about the Booty's Void. The Booty's Void is a very interesting place. Now, what is the Booty's Void? Well, in the constellation of the sheep herder, the Booties, the main star is the bright yellow Arcturus in Booties, and that's Bootes. There's an interesting place where it's an area of space relatively devoid of any galaxies. There's like nothing there. And the funny thing is, when we look in the universe, we see galaxies almost everywhere we look, except in this one particular location in Booties. All right, and that's why it's called the Booty's Void. There's nothing there. Now, is that such a big mystery? Why is that important? Well, first of all, if we look at the way galaxies are distributed in the universe, it's not even. Okay, it's got chunks and clumps. There's superclusters. There's clusters of galaxies and superclusters of galaxies. So there is some reason to believe that there can be when the galaxies formed, that sometimes these galaxies, as they were moving and expanding in the universe, they merged into other clusters, and kind of like soap bubbles, you know, combine to form larger bubbles in a sink. Okay, and that's something, you know, I know that Wikipedia uses that soap bubble analogy, but I usually reserve the soap bubble analogy for the parallel universe world. But in terms of talking about it for the Booty's Void, it's possible that galaxies merged to other clusters and happened to leave this one area of space relatively unpopulated by galaxies that may previously have been there. And they just migrated away and joined other clusters. And so the local gravitational fields of all these clusters, if you can say local gravitational field of a galaxy cluster, set of galaxies in a cluster, is such that, you know, it probably left this one area relatively devoid. And again, it wasn't homogeneous. That means evenly distributed. It wasn't an evenly distributed Big Bang. Okay, there were clumps, and that clumping is the reason we're here. And without that clumping, we wouldn't have what we have now. We wouldn't have the ability for certain things to happen where stars got formed and galaxies formed. That clumping had to happen. So because of that clumping, the Booty's Void probably exists, because objects were sucked into other galaxy clusters, leaving this one location relatively devoid of any galaxies. So that's that's my story on the Booty's Void. If you have any other questions about it, I'll be happy to talk to you about it. It's a big fancy name for just an area of the sky where there seems to be very few galaxies, whereas we see more galaxies all around. All right.
And actually, let me run down a shout-out list for the chat, for the people in the chat. Let's see. I'm just going to go down the participant list once again for the people that are participating in the chat. You got Busta and Chris Yoakum and GM and George Kolosowski. I think I'm saying that right. If not, sorry. James May, Kenneth Cantu, Lunar Sparkles, Sonny, Ted Bronson, and Tim McTurnan, I believe. That's how you say it. So those are who I have as participants, along with Weird Guy that just popped in. Sonny, I think I said. I'm not exactly sure. And for the people that are watching but not participating in chat, feel free to participate in the chat if you want to. Ask questions. Tonight we have Mark D'Antonio from Sky Tour Radio on KGRA. And, of course, he has a Sky Tour YouTube channel, which is Sky Tour with Mark D'Antonio.
Live stream, yeah.
Yeah, Sky Tour live stream Mark D'Antonio here on YouTube. And I'm pretty sure we can post links to that in the chat if you want to subscribe to him. He does a lot of deep space stuff. You're talking nebula, you're talking all kinds of crazy stuff. And he does it live. You're actually seeing the images processed live from his observatory in Connecticut. Awesome stuff.
You've been there?
Yep, been there a couple times.
Yep.
And, yeah, so if you have any questions, he is a professional astronomer. So he will try to explain it the best he can for you. So have at it. And Righteous Toad just popped into the chat as well. So, yeah, if you have any questions. And Tana just showed up as well. I just seen her pop in.
Hey,
so, yeah, if you have any astronomy questions, the guy pretty much knows everything.
No.
Well, you talk about a lot.
See, here's the thing. Astrophysicists study one type of branch of the universe. Cosmologists study a slightly different. They all overlap. And astronomers study the physical structure and evolution of the universe. And so that's my specialty, is that, and I focus in particular on planets around other stars. So, but we have to know, and you do learn along the way, because there's interdependencies, physics-wise and hypothesis-wise, across a number of different disciplines within astronomy. For instance, I got a question here earlier, like, what is dark matter? James May's asking, what is dark matter? Well, dark matter is actually important too, because dark matter may comprise beyond 80% of the matter in our universe. And we can't see it because it's made of some atomic structure that we don't know yet. Now, the reason that we think it's there has to do a lot with the mass of the universe and the structure of the universe and the state of the universe now and its expansion rate could imply that the mass wasn't there to create the universe as theorized, unless there was more of it that we don't understand. And so the concept of dark matter was floated, no pun intended, to account for the other matter. And it's called dark not because it's black. It's called dark because we don't know what it is. That's all. And when we say dark in astronomy, you immediately think black, and it's not that. It's just it's a box we can't see in yet, and we'll be able to at some point. But so dark matter is this invisible matter, radiation, in fact, energy density, if you want to call it that. But it's stuff that we know influences, for instance, the evolution of the universe, the evolution of how galaxies form and how they stay together and how they interact with each other. Dark matter has a role in all of that, possibly. And I say that because even dark matter is still theoretical, all right? Typically, you have another component there, and it's dark energy. Okay, now dark energy is another thing that we don't know much about. So we have dark energy and dark matter. And again, most of the universe that we see comprises about just a few percentage points, 4 or so percent of everything we see in the universe is in that little area, 4% that we know. Nothing else beyond that is something that we can actually put a structure around yet. Isn't that amazing? I mean, for only knowing 4% of the universe, maybe 5 or even 6, for knowing only the small amount of the universe, isn't it amazing to think that we actually have gone out beyond Pluto? We've got probes that have already left the solar system via the Voyagers. They were past the heliopause, the point where the sun's influence basically drops off. And in that time, we only know a small amount of what's actually there, yet we can still do this. I think this is kind of really interesting. It's interesting. Now, dark matter doesn't fit everything. Okay, there are reasons why, and we don't know the true extent of dark matter. But we do know that dark matter of some form is out there because we can see what's called gravitational lenses, where a distant object's light is distorted by something between us and that object. So the distant object's light is actually changed. We know that planets cause that. We have actually discovered planets using gravitational lensing, where a planet passing around its star doesn't go in front of its star because the angle's not right. But when it goes in front of a nearby star that's farther away, light years behind it or something, the light from that distant star is changed by the planet's own gravity. And that change causes what's called a gravitational lens. The light bends. And we've seen this with the sunlight during eclipses. The starlight that we can see from the sun during these eclipses actually can change in the sky, indicating that the moon's gravity affects the starlight positions and the star's position. So we know that it happens. It's a real effect. It's measured. It was predicted, and it actually happens. And now the benefit of the dark matter is that some of the things we don't understand are understandable, like how galaxies stay the way they are, the evolution of the universe, the missing mass. On the other hand, there's things we do not understand at all that dark matter can't answer. In fact, dark matter causes problems for. So I think we're on a sort of a revolution in astronomy, learning what the real nature of the universe is. I think discovering quantum entanglement, which we talked about earlier, is something that's really important. And I think that over time, we're going to have a better feel for how this quantum effect actually causes farther reaching influences in our universe. So there, I mean, that's sort of dark matter a little bit, and dark energy even lesser bit there. But I hope that kind of gives you an answer.
You want to answer Tana's Nibiru question? Nibiru? Nibiru?
What did she say? I didn't see it.
She said, Mark, have you spotted Nibiru? Nibiru.
Oh, well, she just has to look at my homepage, my Facebook page, and see. Yes, I got a photo of it. I put it up.
Yep.
I grabbed the picture off the NASA feed before NASA went dark.
And NASA erased it.
Yeah. Actually, it was an internal lens reflection or a lens flare, one of the two, and it was actually blue because the predominant color was the Earth color, which was the brighter color in the image, and so that ended up being most of it. And it actually kind of looked like a second Earth. It was really nice, and it looked like a waxing gibbous Earth, in fact, in a phase. But it was obviously the light was all wrong for that, but still, it was interesting. And I put it up and said, "Look, it's Nibiru," and then of course said, "No, it's not," and here's why. But there's and that's the other thing too. People, they make these statements. Well, we got this planet that's orbiting every 30,000 years and so forth. Well, 30,000 years is just a drop in the bucket for this solar system. And let's say it was even 10 million years, or even a quarter of a billion years. Okay, if we had something come in.
Well, let me just tell George real quick. George, any of the scopes that we're using currently is in the top right of your screen, just so you know. And we do switch between scopes. So as of right now, it's the 11-inch Celestron.
Oh, cool.
Continue, Mark. Sorry.
That's all right. So let's see, where was I? Trying to figure out where I was.
Good luck with that.
I was answering someone's question. Was it Tana's question?
No, it was Nibiru, and then you went to...
Sorry.
Yeah.
Yeah, and the fact is, even if it was like a long period, like a quarter of a million years or 250 million year orbit, or 30,000 years, why would we know whether that was happening or not? We would know because if you look at what happens to the current orbits of our planets, if another interloper comes in, we discover that the solar system as it is could not exist if we had this periodic planet coming in, because this periodic planet would upset the orbits so much. And again, remember, we think in terms of minute to minute. We don't think in terms of millions of years to millions of years. As a planet comes back periodically like that, like some massive comet, say, you know, with lots of gravity, like people suggest, it will actually cause the orbits to disrupt in such a way that they would not at all be like they are now.
And we did that in Universe Sandbox as well.
We did, you know, and we kind of we're doing it fast, and that, you know, eliminated a lot of the accuracy, and that's sort of a toy. It's a sandbox toy, but it does give some fairly coarse.
Well, if you have the processing power, because I mean, the Universe Sandbox does take a lot, because it's processing calculations like crazy, and you have the time to watch it. You can actually create a Nibiru, from what people say that it is. And you can actually bring it in from past the solar system and watch how early and how many years and decades and centuries it starts affecting our known orbits of the planets. Yeah. Until they start acting funny. You'll be able to see it so far away, even, might I say, to the point where, and I hate to say this, but to the point where we might even, its effect might be the only thing we know since we've been studying the planet. You know what I mean?
Yeah, we would, if there was something out there like that, you know, let's say it's all the way out in the Kuiper Belt right now. Let's say there was something coming in. And let's forget the fact that the orbits in our solar system would all be disrupted, the inclinations especially. All right, like Jupiter's orbit and Mercury and Venus and Earth, they're all kind of in the same plane. Well, that would change. The inclination of Jupiter's orbit would change radically within the Nibiru introduced. The inclination of Venus and Mercury's orbit would change, but we don't have that. So that aside, if we did have something way out in the Kuiper Belt, it's quite conceivable we might not know it yet. However, if it's there, it would be given away by something else, and that's its gravitational influence on Pluto, on some of the other Kuiper Belt objects that we do know, like Eris and Keor, Sedna. We'd see that on those. And we would also see it on Neptune and Uranus and Jupiter and Saturn. We would see that influence. We would see the perturbations. And that is, you know, the differences, the small disturbance to their orbits. We'd see that. And those are called perturbations. You know, so we would actually see that, and we would actually be able to say, well, this is happening because it's being influenced by some object. And to give you an idea of how good we are at that, keep in mind that Clyde Tombaugh, who discovered Pluto, was seeing inconsistencies in Neptune's orbit. And he said there's got to be another planet. And he went hunting for it and eventually found Pluto, where it is. Okay, so clearly we can see perturbations, even small ones, from a tiny little planet at the time called Pluto, which isn't even now a planet status anymore. It's a dwarf planet. So that said, you know, we can see gravitational perturbation that far out. All right, the fact that we don't see any right now that we can't account for tells me and tells most astronomers that we probably don't have, make 99.99999%. We don't believe that we actually have an object out there that's destined to come in here and wreak havoc. And no, there's no thing out disrupting our magnetic field, causing more earthquakes than normal, and hurricanes are especially bad because of Nibiru. You know, that stuff is all just hoax crap, to be honest. And, you know, I go to the wall with that, and I'll fight anybody who tries to claim otherwise, because that's just ignorance of science, frankly. And you can't take 2 and 2 and make it 5. Okay, you always have to say it's 5 minus 1.
Yeah,
okay?
And as it always has been said, your lack of understanding of the evidence is not evidence against it.
That's exactly right. And I like that. That's a good phrase. You've said that before. And I've actually given you credit for saying that before. I
forget who actually originally said that.
Huh?
I forget who actually originally said that.
Yeah, I don't actually know. Actually, I think it wasn't said the same way you said it, but the way you said it is actually easier.
Yeah.
Understand. Tana's asking, you know, how much of our galaxy have we actually explored? Well, guess what? we don't even know what our galaxy looks like, you know. I mean, we do. We have a sense. But by looking at other galaxies, we infer what our galaxy looks like. And why is that? Well, because we're in the forest in our galaxy. That's like trying to map the forest from, you know, from inside the forest in any kind of national park. Good luck with that. You know, how are you going to do that unless you can travel to all the far reaches of the forest and measure your steps, measure your angles and of where you're walking? We can't do that within our galaxy. We can only do visual observation. So imagine trying to map a forest from where you're standing in the forest and looking around you. You can only get out so far before the trees block the further distance away, or before you can't see any detail anymore.
And don't get him wrong, visual observance is very important as well. Because once again, with the science that we do, you know, it has to match what we see.
That's right.
Which is why we know about, you know, how flat Earth isn't real and all that stuff. Because if it were, nothing that the flat earthers have brought matches what we actually see.
Exactly so. It only serves to disprove their points rather than prove it.
Right.
So, I mean, if we want to look in the forest, say we want to look deeper into the forest, we could use other things. We could use, say, infrared telescopes and look deeper into the forest, see anything that's generating heat farther out in the forest behind the trees, and that works. We could look for other radiation coming from the forest. Maybe if there's an X-ray source or a cosmic ray source out in the forest, we can look through the trees, and that will come right through the trees. We'll see X-rays, you know, possibly coming in, or cosmic rays coming in. All right, and that helps us map out what the galaxy looks like, you know. And I'm calling the galaxy a forest because that's really what it is. It's just made of stars. Now, the center of our galaxy is toward an area of the sky that right now, at around 10 o'clock, 9:30 at night, is just about due south, just a little bit southwest. Okay, and it's kind of from the northern sky, from the northern hemisphere. It's due southwest, you know, this little bit. Right now, about 9:30, and that's toward the constellation of Sagittarius, and in particular, it's called Sagittarius A. And it's the direction of what might be a large black hole in our galaxy. And based on the star distributions that we see in our galaxy, we think that our galaxy is not an ordinary spiral galaxy like the Andromeda galaxy, M31, Messier 31, that's 2 million light years away. That particular galaxy, which is also heading for us, is a spiral galaxy. It has these large sweeping spiral arms, and the stars are circulating around the galaxy every, probably more than it takes ours. Our sun goes around once every around 230 million years. You know, we've gone 19 and a half times around our galaxy since we were formed. And in Andromeda, it's going to take more because it's a lot bigger galaxy, probably close to 1 trillion stars there, whereas we may have 100 billion, possibly as high as 400 billion. So a lot bigger, a lot more stars. But looking at the structure of Andromeda, we see a true spiral galaxy. I put up a post about showing the Andromeda galaxy that we took right here at Sky Tour Livestream. It was a 30-second exposure. But if you look at it, you can see with clarity a lot of really nice detail. You've seen that, right, Keith? You saw that image we took.
Yep.
It's
and actually, we're gonna make a shirt with that image. We talked a little bit about it. My idea for that. What's that?
Put a "You Are Here" on it.
But you know, talking about this, it is why people like myself are so excited about the James Webb Telescope.
Oh, yes.
And that thing's going to be powerful enough, and it even has been talked about among astronomers and scientists that we might, because Mark is a specialist in exoplanets. That's planets around other stars besides ours. And with this James Webb Telescope, it may be possible to see planets around other stars, kind of like we see with Jupiter's moons with our telescopes. It may be possible.
Yeah, there's something beyond that too. We're probably going to be able to see. We'll be able to see these exoplanets that we think might be promising. We might actually be able to look at their atmospheres and detect what their atmospheres are made of. And it's important for us to be able to find a planet like ours. I'll tell you why in a sec. I just want to finish that last point about the shape of our galaxy. Yeah. Because I didn't get to finish that. I should have.
Go for it.
The shape of our galaxy, it has a concentrated bar of stars kind of down the center. Okay, and then the spiral arms come off of that. Now we have spiral galaxies. We have elliptical galaxies. which are just big collections of elliptical, convolutions of stars there. And these galaxies that have this bar, this middle bar of stars, a heavy concentration, it turns out that we might be one of those. And those are called barred spirals. You can see them out there. If you look up barred, B-A-R-R-E-D, spirals, you'll see pictures and you'll see what I'm talking about. We might be one of those. And if that's so, then it means that we had fundamentally misunderstood the nature of our galaxy for many years. But it's understandable. We're inside the forest trying to map the forest. If you're inside the forest looking across at the opposite hills, you can easily map those out. You can see from there, you can see what you see. Okay, looking through the trees, you can see the other forests on the other side of the valley and map them out. Fine. But your own, you can't see, and that's part of the problem. So going back to this other thing now with James Webb, the James Webb Telescope is going to be really good at seeing these atmospheres of these exoplanets. So we've got many planets that are on the docket to look at with the Webb that are going to be primary targets. We don't have the capability of traveling interstellar yet. We will. And why? Because we already see for our 5,000-year history-keeping lifetime, and I'm not counting petroglyphs and pictographs and caves. I'm counting, the Sumerian cuneiform, as I've talked about before, the first kind of written language. That was about 5,000 years ago. So from there to here, we already see ways to circumvent the speed of light in a very real way. And, Sonny White, Dr. Harold Sonny White down at NASA, has a funded lab looking into this because they've made practical, in a sense, the possibility of warping space. You may think, well, that's just Star Trek. That's fantasy. No one knows what they're talking about. Well, actually, Gene Roddenberry, who invented Star Trek, was no slouch. I mean, he understood some of the scientific theories. And knowing that space is made up of what they call a space-time continuum, or the fabric of space, there's a mathematical definition for what space is. It's not just nothing. There is a mathematical structure that dictates what space is. And we can modify the structure of space by imparting certain forces through gravitational means.
Right. I want to try to keep up with the questions in the chat. Kenneth asks why they call it their Bay of Rainbows. I believe it's Latin. It's like Latin for like Bay of Rainbows or something like that. And that's been popular since back in the 1600s when it was given the name. But and then we have let's see. I just saw it up here. Somebody had commented on the James Webb. Oh yeah, okay. Tim, James Webb was supposed to fly 5 years ago. Never a straight answer. Original. Yeah, is waiting on something. They're not waiting on something. You have to realize with the James Webb Telescope, they only have one shot at it. It's not like the Hubble where you can go up and put it in orbit and work on it. This thing has to be absolutely perfect from launch to out at, what are they putting at, L2?
Yeah, it's actually
where they're parking it at.
It's going to be in a parking spot in space, one of the garage points.
And we can't reach it.
Right, we're not going to really get to it to fix it, so it's got to be right the first time.
So everything, I mean, you're talking about from launch to get it up there, to get it out to the spot, to everything unfolds, and it has to be perfect. They get one shot and one shot only at it. And they keep putting it off because they want to make sure that they get it right. And I don't blame them one bit. I don't care if they take to 2025 to get this thing up. As long as everybody that has worked on it, everybody that is working on it is confident that this thing is going to go. This includes the people that built the rocket, that they went through their, checklist of everything 70, 80 times over to make sure this rocket's not going to blow up at the launch pad.
Yeah.
To making sure all the mechanics work, making sure, we can have the signal. But that's why they're taking so long with this. And I don't blame them. And the return possibility of what we're going to get out of the James Webb Telescope is going to open an entire new space plethora of answers that we have wanted for a very, very long time. It is going to be comparable to, us going to the moon, actual launch. I mean, we're going to see basically so far back in time when this thing gets out there. It's going to answer a lot of questions that haven't previously been able to be answered. with certainty.
That's right.
So that's a little bit about the James Webb. My opinion, anyway. What do you think, Mark?
Well, yeah, I mean, the James Webb's primary instruments are going to be infrared scopes. So, I mean, the infrared systems, you say, well, that's not real light. That's infrared. Why are we looking at that? We're looking at that because that's going to tell us the information we need to know. When you look at the infrared spectrum from a atmosphere, you can detect a lot of things. Okay, you can detect a lot of substances in the atmosphere that you might not otherwise see. And I think that by looking at the atmospheres of these exoplanets, we're going to find, I believe we're going to find the Earth's twin this way. And, why do we do that? Well, we're looking for carbon-based life. Why is that? Well, because carbon-based life is what we are. It's what the universe provided as a template for this planet, because carbon-based everything was delivered to this planet, and the Earth made the carbon-based stuff by itself. So clearly that's going to happen elsewhere. So yes, we're a little bit of carbon bigots, yes. Okay? And as carbon chauvinists, we do know we have to look for other carbon-based life, at least to start, because it'll be there. Carbon's one of the most common elements, and
that's one of the signatures that we use to find life as we know it, as we
right.
know life to exist. That's not saying there aren't some species out there that are using nitrogen or hydrogen or sulfur as their.
Well, we do know that there are. I mean, we know that the sulfide chimneys down at the bottom of the ocean, they're using not photosynthesis, but chemosynthesis, and they're living off methane. This is we're talking about little sea creatures that are getting energy and basically food from methane. And you look at methane and you say, wow, that's kind of interesting. I think that methane is a substance that is pretty much ubiquitous throughout the solar system. And it's basically carbon with 4 hydrogens on it,
Mm-hmm.
and that's something that is really important for us to consider. That that's basically the food stuff of bacteria.
Not to mention they have to be able to see a planet. Can you imagine being on a planet where the sky wasn't blue but it was red?
Yeah.
Tell me how awesome that would be.
Yeah. Well, that would just mean that we're looking at an atmosphere that's actually absorbing and scattering the red light more than the blue light.
Yep.
Because here on Earth we see blue light because the white light from the sun is broken up into the prismatic rainbow by all the molecules in the atmosphere as it hits, and they absorb them. But they are most efficient at scattering back to the sky in all directions the blue light, the higher energy light, and that's why our sky is blue everywhere we look. And there's something else, here on Earth, which, you think, wow, if we have a nice, clear, dark sky, it'd be beautiful. Yes, it's true, but we always have something else that gets in the way. Even in the darkest sky on the planet Earth, when you take a deep sky photo at night, you end up with a glow on your image, and you're like, what is that? It's not distant lights. Let's say you don't have any lights. Let's say you really don't have any lights. It's not distant lights. It's not somebody lighting up a flashlight at a campsite. It's actually the glow of molecules in our atmosphere. It's called air glow. And there's different layers. There's a sodium layer down low. There's an oxygen layer. And you literally have air glow that's reddish, green, and yellow. And that's something that gets in the way of really deep photographs of the night sky. We'd never see it, in any kind of, light polluted skies whatsoever. And you might not even see it from skies that look nice but aren't fully dark. You really have to be in a fully dark area to see the air glow on a photo, like La Silla down in Chile, or Cerro Tololo down there, and Teide out in the Canary Islands might see it. Okay, but that's all part of the fact that we have these molecules in our atmosphere. But this is the kind of thing that the James Webb Telescope is going to look for, and if we see that, that's going to infer what the atmosphere is made of. And keep in mind, if we see oxygen in an atmosphere, okay, diatomic oxygen, like here, O2, 2 oxygen atoms connected, this tells us something. It tells us that something's replenishing that oxygen. And the reason is, we've talked about this before, that oxygen goes into the ground and into the soils and rapidly oxidizes and connects to and bonds with other atoms. Like, for instance, if there's iron compounds, it loves to bond with iron, and it makes iron oxide. It did that on Mars, and that's why Mars' atmosphere in part thinned out, and that's why Mars is red. It rusted, see? And we talked about that too. So there's so much, you know, and the Webb is going to look at that stuff too. And you know, if we see oxygen, it means something's replenishing it, and that something may very well be life. Not necessarily intelligent life, but life. And really we're answering that question first.
Can you explain to Mr. Busta in the chat that believes you're indoctrinating everyone?
I am.
To explain to him how we know what elements are in, like how do we know where, you know, methane is in space, or how do we know if something's hydrogen or oxygen? You know, well, there's a certain thing that you like to do called spectral analysis.
Yeah. Well, see,
and do you want to explain how that works for our friend here that doesn't seem to understand?
Well, that's okay.
And maybe might want to be indoctrinated a little bit by you.
There's no stupid questions, you know, and Busta's right. I am a government plant, and I'm totally just spewing stuff that NASA pays me big dollars to say.
Oh, yeah.
You know, so he caught me. So I have to
everything's a conspiracy.
I am indoctrinating you. It is totally conspiratorial. All right. So no.
This indoctrination looks a lot like education.
Shh, don't say that.
That's how they get you. That's how the Illuminati wants to get you.
Look, I'll give you an example. When you look at the atmosphere of our planet with a telescope right here, I've modified several cameras so that I can actually get extended information from my camera, and that extended information comes in the infrared band and a little bit into the ultraviolet band. When you look at the atmosphere with these very sensitive cameras, one thing you'll notice is that when I take pictures, that is, of like spectra. And what are spectra? Spectra is when you take the starlight that's coming in from the sky and you spread it out into its component colors. You see red, orange, yellow, green, blue, indigo, and violet, you know, primarily for like a regular star. And we call that Roy G. Biv, you know, it's a little name. Okay. Well, that red, orange, yellow, green, blue, indigo, and violet color scheme is something that is important because within those colors of the spectrum, if you're breaking up the light into the spectrum, which we use, it's called a prism or a grating, a diffraction grating. I use diffraction gratings. Well, when you do that, you get a broad color spectrum, you know, that goes gradually from red to orange to yellow, etc., on down to the violet. But in there, you also see these dark lines, vertical lines. What are those? Well, see, those are where the starlight that you're looking at is, the star is generating energy in its interior. And the outer atmosphere of the star is lower temperature than the interior temperature of the star. So when that interior radiation goes powering through that outer lower temperature gas in the star, that outer gas in the star absorbs a little energy. And when it does so at a specific place depending on what element it is. So if it's hydrogen, then we have what are called hydrogen lines in the spectrum. And they're dark lines. And there's several series. There's Lyman, there's Balmer. Okay, these hydrogen lines will show up exactly where they're supposed to be. We know exactly where they are in the spectrum. We can tell you at what nanometer location. That's a billionth of a meter. Okay, a nanometer. We can tell you where they are in the spectrum, and that is from doing spectral analysis. I routinely take spectra of stars, and I can see that, for instance, Vega has very, very bright hydrogen Balmer lines. You can actually see hydrogen alpha, hydrogen beta, gamma, delta, all the different lines. That's how they're labeled. All right, and we can identify them that way. Well, in the same way, we can see methane. We can get the spectrum of the methane molecule in the atmosphere of other planets, okay, like say Jupiter or Uranus. Okay, we can take a spectrum of that reflection and see, because it's reflecting sunlight, we actually see the sun's spectrum coming back to us. I actually have a spectrum of Jupiter that I took that shows the spectrum of the sun because it's reflected light from the sun. And in that spectrum are additional absorption lines. That is, these dark lines I was talking about, where the outer layers are absorbing some of the light from the sun before it comes back and reflects. And we now see that, and that's like it's called a contamination of the spectrum. It's contaminated by the planet's own atmosphere. Well, the Earth does the same thing when we take a spectra of the stars, especially if you've modified your camera to see other things. For instance, water vapor in our atmosphere produces dark lines farther out into the red end of the spectrum, the infrared. And those are called telluric lines, Telluric, telluric lines. Look them up if you want. And telluric lines are a very characteristic signature of water vapor and other things, and you can see them showing up in your spectra you take of stars. It doesn't mean you've discovered water vapor in the stars. It means you have contamination in your stellar spectra from the Earth's own atmosphere. And so we have to separate the two to really get an accurate portrayal of what we're seeing. So we do this analysis to tell us the chemical components in a star. It works for planets. It works for exoplanets. And when the James Webb goes up, you'll see how well that's going to work. And it works for other things too. So, I mean, we have a way of actually determining the elements that are in our periodic table that are showing up elsewhere.
There you go.
There you go.
Explained. Reflection equals absorbing light. Well, yeah, reflections absorb a little bit of light. Mirrors absorb a little bit of the photonic activity.
Well, actually, reflection...
Which is why you can't step into a round ball and light a flashlight and it continue to be lit when it's done, because you lose a little bit. But
I don't know. See, he's making these pronouncements.
Yeah, he still calls BS anyway, so you're just wasting your time. So
that's
whatever.
Okay. I'm not doing this to make sure other people don't listen to what he says and take that as because he's trying to indoctrinate on the other side to his way of thinking. So it's like, why indoctrination? I'm just going from formal education. If he doesn't like that, well, then he can get a formal education and re-indoctrinate me his way.
Write a thesis.
Yeah, I mean, if he has the credentials and the education behind him to do that, I will listen.
But it's all indoctrination. You went to.
The thing is, though, let me just make sure I understand. Make sure it's clear.
Yeah, I don't even understand.
I have talked to people that have never gone to college, and they have taught me a great many things. You have to just keep your ears open, because sometimes people in their observations tell you something you never realized, and I've had that happen a lot of times. Unfortunately, Ballbuster ain't doing it. I apologize, and I appreciate, though. I know he loves the stream. I know he does.
Yeah, he's here all the time.
Yeah, I think that if we look at what he's asking, clearly he's asking questions it's a little controversial. He's kind of trying to poke a stick at us. That's okay.
I mean, he's living up to his name.
Yeah, and that's fair. Let him do that. I mean, because look, I won't
just want to bust some balls. You know what I mean?
yeah. I'm not shrinking from questions. Because
something tells me. I mean, I like Busta. Busta's been here for a long time, which is why I haven't dropped a ban hammer for annoying me yet. But he's been around here a while, and I entertain him a lot. Just because some of the stuff he says, and yeah, I think sometimes he's doing it just for the fact of being contrary, and
that's fine.
Just to have a difference of opinion than everybody else.
Okay.
I have been
cool. I've been on stage in front of hundreds of people and getting questions from people that are extremely controversial, and they contradict some of the things I've said, and they also are confrontational questions. So you have to know how to handle people like that. You can't just say, "Well, you're wrong. Now sit down, or I'll have you thrown out." I mean, that doesn't get anywhere.
Sure, I can.
And that's the difference between.
That's what I'm saying. I mean, Busta's been around here for a while. I mean, we've had really good conversations in the past, and I actually like the guy. You know what I mean?
Yeah.
Which is, before I would have just,
Jenny, you're funny.
But when it comes to simple stuff like moon rotation, and then I do my best to try to explain how it rotates and why it rotates, and how it works, and then you go through all that just for one person. That whole thing that you guys seen tonight, with a demonstration of how the moon rotates, was for an audience of one. That actually helped all you guys out, because I realized a lot. Even some of the mods on here didn't realize that the moon actually rotates. But just to visualize it for them, to show them exactly how it works. And then when he's I still don't believe it. BS. It's like, never mind. It's like, why even bother? You know?
Yeah.
Like, if I thought it was sincere, and like you really didn't understand it, I mean, that's why I did that. You know, some people can't wrap their head, like some people even still after seeing that still can't wrap their head around it. You know?
Yeah, I understand.
And that's why that's why the color, that half of the moon, we colored red, so you know what side we're always looking at. That represents the side that we always see.
Yeah,
you
that's
know?
fair enough.
And once again, I'll put it on screen again since we're, you know, on a cloud. Paul said it is going to clear in about 5 minutes or so. We're just waiting on this one thick cloud. And welcome to David Schmidt that just joined us. Actually, let me run down this real
I meant
quick.
to say hello before.
We got Tana and, of course, Busta's here, and Belinda and David Schmidt and Easy to Kill Me. Oh, what a name. James May, of course, Jenny Miko, our energy pirate, Jenny Miko. MMT, Jello is here as well. Nancy, Outrageous Toad, Starseed, Ted Bronson, Tim, and Weird Guy are all, you are hanging with myself, Keith from P&K Space Imaging, and Mark D'Antonio from SkyTour Radio and SkyTour Livestream. And NASA's Unexplained Files, and What on Earth, and you know, whatever else.
Yeah,
you're like one of those guys, and just say, "Hey, Google me."
No. No, then they get this guy in University of Michigan who's a football coach.
Yeah, right.
No, they do.
Get Race Hobbs on here one night.
Oh, Race is great. Yeah, Race is
that big booming voice.
Yeah,
Race Hobbs.
He has a beautiful radio voice. You know, he is really, really got a beautiful voice. The guy's got a nice, low voice. I mean, man, you can listen to him all day.
And it's hard. It's hard to imitate, too. Like, that is just a low, booming voice.
Yeah.
Like, if you picture, like, a redneck god, and I hate to put him in that, but, you know, he does have a southern accent. And it just is just, you can't recreate it.
No, you know,
it's just
and
a booming voice.
I'll see Race in a couple weeks at Devil's Tower. He's going to come out, actually, which is really nice. He wants to come out and see us. You know, he's just fantastic. As you know, he now lives out in Ogden, Utah. So he's going to take the KGRA crew and head out to Devil's Tower. It'll be fantastic.
Hello, everybody.
Yeah, that's almost good.
That's a little too low. Hello, how are you?
Sonny's asking a question here. He's saying, what do I think of the theory that black holes are believed to exist at the center of a lot of galaxies may instead be wormholes? Well, okay.
Wait, hold on. Let me see if I can find this here. Okay. Mark, what do you think of the theory of black holes that are believed to exist at the center of a lot of galaxies may instead be wormholes? I know I had to read out loud to myself, so I understood.
That's okay.
Sorry.
Well, okay. There's a theory that, you know, we do have a theory which makes sense. That there are black holes in the center of larger galaxies and possibly in the center of all galaxies. And that's what's basically holding them together, at least initially, because the gravitational influence of a black hole is only as strong as its mass. And initially, the black hole's mass is not going to be high if it's just a collapsed star, but it can attract other stars to orbit it. And just because it's a black hole doesn't mean it's going to start pulling in everything into it. That's not how it works. Black holes will, you know, just have the mass of the original star that formed them. If our sun became a black hole, we wouldn't suddenly get sucked into it. We would just continue orbiting as we always have, because the gravitational force doesn't change. Whee! However, if a star or another planet comes into orbiting the sun new, and over millions of years collides with it, well, then the mass of that planet or star gets added to the black hole.
Do we have a blinking light around the moon edge? What is he doing? I could have swore I saw like something blinking off the edge of the moon there.
I think he's
maybe he didn't. Okay.
Seeing one of the water spots.
Well, usually Paul, if he sees something, he'll go to it and like be there, and I have no idea until like 30 seconds later when he texts me. He said, how about that or something? Yeah. I'm sorry, I didn't mean to interrupt you again.
No, that's okay.
Yeah. Go ahead.
Cool. Here. So anyway, so
totally threw off your concentration.
No, I know where I am. I mean, I'm not going to forget this time.
All right.
I know that black holes are actually probably in the center of the galaxies. Sagittarius A, we can tell by the radiation that's being emitted. Black holes don't let anything but, even light escape them. But you would say, well, then how come you can see, huge magnetic fields, and how come you can tell, why do you get X-rays and gamma rays? That's light. Why are we having trouble with that? How come that shows up? Okay, magnetic fields aren't, obviously. We're talking about something else there, but But the X-rays and gamma rays and so forth, well, the reason is because at the surface of the black hole, the event horizon, the area where there's that transition zone beyond which nothing can escape, and that's true, nothing can escape. At that surface point, there's a lot of interaction going on with the strong magnetic fields and with radiations that are generated on the surface of that event horizon, and you will get a lot of X-ray sources coming from the black hole. So we do have X-ray sources in the middle of galaxies that may very well be emanations from these giant black holes. As far as being wormholes, well, the theoretical structure of a wormhole is that it's not a lasting object. It's going to not just sit there permanently. Wormholes don't sit out there in physics and just sit there and stay there forever. They're not stable. They come and go, maybe never the same one twice. So I don't believe that wormholes, for instance, will be a future mode of travel. I think that wormholes might be a curiosity, but they won't be out there as like travel networks and travel nodes. I just don't believe that. And now Tim's asking, do I think some gas giants that we're finding have moons that are Earth-like? Okay, well, there's a lot in that question. Let me ask you this. Let me say this, okay? We see some gas giants out there like Jupiter, and there are some that have very large moons. We even even here in our solar system, we see Saturn. Saturn's the second largest Jovian planet, and it has a moon called Titan. Titan is as big as a planet, and so and it has a heavy nitrogen atmosphere. And under the right circumstances, Titan, if it was a little closer to the sun, if the sun was hotter, Titan could become an Earth-like planet. Now, yes, the nitrogen atmosphere is not something we could breathe, but see, all of the processes that would create oxygen on Titan are kind of locked up because of the extreme cold. Warm it up and things change. You start getting methane production. Methane gets decomposed into hydrogen, gets decomposed into carbon dioxide. Carbon dioxide can be split apart. You can get oxygen out of that. You can get oxygen from water vapor that's now liberated. So warming up a planet will certainly give it the capability to generate new components in its atmosphere. So I think that's something that's really important to understand. Right now, it's not. But we look at Titan with this promise of thinking, hey, if we could ever terraform it, or if we could ever get it warmer, we could actually start the process and let the planet take over and do it itself, terraform itself, So you're welcome, Sonny. I hope that helps. So I think that's kind of where we're going to go with that,
Right.
Anyway,
I believe David said something about maybe having a question. You're gonna look back here in the chat.
Yeah, he's actually asking it now.
Oh, okay. And welcome everybody to a nice Friday, well now Saturday morning, hanging out.
And I'll be heading
the
out.
moon.
I'll be heading out soon, but
No, you won't. You ain't going nowhere.
oh, I think I have to.
No,
But
you don't.
I got to tell you this, though, guys. I got to tell you all this. And David, I'll answer your question in just a minute about the EM radiation. That's a very good question. I actually I got a very high resolution 3D model of the moon that I just finished assembling, and I just printed a 3D print of the front half of the moon. That is to say, the northern hemisphere of the moon, and it came out gorgeous. So I'm going to print the bottom half, and we are soon going to have, and PK will offer them, I'm sure. We're going to have moons for you that are about 4 inches, maybe 4.5 inches in diameter. As beautiful models, all painted like the picture you see, on the moon you see. And it's going to really, really be pretty. So we're looking forward to doing that. I just got the northern hemisphere printed now. It looks beautiful. And we'll do the southern one in the next couple of days. Anyway, I got to do something while my SkyTour live stream camera's down, for a week or two. But I'll show it to you, and I'll have Keith put it up so you can see it, so you can check it out.
Yeah, the preliminary one I saw was really, really neat.
Yeah, and I made an even better one since then. I showed Keith. Now, David, your question.
By the way, before you go on to that, I just want to let everybody know the moon that you see in the inbox down there is from Chris over at Take Back Space. He's also streaming right now, so I figured he was clear, so I just put it up on screen so you guys can see the clearness from Tampa until we clear. Just so you know.
Where is he? Is he in...
He's in Tampa, Florida.
Oh, he's in Tampa?
Yep.
Oh, okay. Because I was going to say, it's really fun if you get somebody from across the country and bring that up, and then you actually see the differences in the images, the way they look, because their perspective of the moon is a little bit different than yours.
Well, it's even good even having Chris in Tampa. You know what I mean? Because if we do have an object, it's nice to know if it happens to cross his path as well.
So, yeah.
That tells us something that's a little closer to the moon. You know, whether so it always helps. And Chris is a great guy. And if you guys haven't checked out Take Back Space, jump over there and say hi to him at least. Tell him Keith sent you. I'm sure he'll love that. But he was in here last night with us for a little bit, and over on his channel he does stuff a little bit different. He does have a 4K camera there at the moon, and I believe he does have an 11-inch telescope that he just got. He was using a 8, I want to say maybe, but he is a musician as well, so he makes his own music, and what he plays during his moon streams is actually him live on a guitar. Or if he's not playing live, he's playing his tracks and stuff. It's a really good stream, and I suggest you guys check it out and subscribe to him as well over there. Really good stuff.
Cool.
Really dedicated too. He does a lot of long streams like we do, so it's always good. And I always have him open on the laptop here to the side just to see, for comparison reasons. If something crosses, I can look over and check out his stream to see if it passes his as well. We both have clocks and we can line up the times and everything. So check out Chris over at Take Back Space.
You can actually confirm the orbital altitude if it's a satellite by looking at the difference of the location that it crosses the moon from him to you, to Paul.
Yep.
If it looks different, then you actually can see. Now it depends on somewhat on the latitude. The longitude will give us entry and exit points that are a little bit. Timing will be different. But that'll be pretty cool. That's pretty cool.
Yeah, and he does it for the same reason we do. It's like we always say, the more eyes on the moon, the better. Whether it be small telescopes, large, it doesn't matter. If you have a telescope and you don't have nothing to do and you want to invest in a little, it doesn't have to be like we do it. We have a lot of customized stuff, including the camera, that gives us a little bit of an edge on, on how we work things. But if you have a small telescope and like a normal astronomy cam that you can connect to a cheap one, stream that stuff. Archive it, on your own channels.
Yeah.
You never know. You never know what's going to happen. And the more people we have across the country doing it, the better. Because then we can,
just flew across here. There's definitely a local object and won't be on his.
Yeah. We can use it for cross-referencing. It doesn't matter. The only thing you want to make sure you do is you do want to have a clock on screen so you have your local time. Makes it a lot easier to compare stuff.
Yeah.
So now you can continue.
Can I answer Dave Schmidt now?
Yep, go ahead.
Dave Schmidt asked if the EM radiation from a star is, the electromagnetic radiation from a star is evenly distributed across the star's spectrum, like a white noise, or does it have a central frequency with the harmonics on either side? Well, actually, the EM radiation is not evenly distributed. For instance, hot blue stars, the O stars, are the hottest stars, 30,000 Kelvin. They're going to have a peak that's more in the blue end of the spectrum because its higher energy light is bluer, and you could even get some X-rays out of those, and down, and of course high ultraviolet. And then at the other end, at the other end of the spectrum, you might, another bird just flew through. At the other end of the spectrum, you might have a like a G star like ours, and you have K's after ours, and then M's, and they're cooler substantially from the previous. And when you have these cooler stars, the frequencies that are being transmitted tend to be more toward the lower energy end of the spectrum, unless there's special events like ultraviolet flares, which M stars are really good at. Okay, so you do get a focus. Now, if we look at just the regular continuum of light that comes from the stars, the O stars have more blue than any other color. The G stars have yellow and white more than any other color. The M stars have more red than any other color. That's how that goes, and that's why we have the stars classified into these different spectral classes, you know, O, B, A, F, G, K, M, from hottest to coolest. And so, yeah. And yes, you ask also, do the frequencies vary with the type and size of the star? Well, the larger a star is, if it's a star that's like an O star, hot blue star, the size is still going to be a hefty ultraviolet component. But if it's a star like the Sun that has reached the end of its lifetime and it swells to be a red giant because it's run out of hydrogen fuel, well, that's different, because now the outer areas, the outer layers of the star are very far from the core, which is the hottest part of the star. So they're going to be a lot cooler. They may only be about 3,000 Kelvin in temperature, as opposed to, you know, 10,000 Kelvin like our Sun, right?
Yeah.
And if those are cooler, then the primary radiation flux that you're going to see is going to be more in that red end of the spectrum. So, yes, to answer your question, the size of the stars and, you know, their output and so forth does make a very big difference on what we see as the primary radiated wavelength we see.
I should say, by the way, guys, we should take the vote on the name. We were talking the other night, Mark, about naming our subscribers. You know how a lot of people do. And the two ones that were, we were thinking about Moon Dogs, or we were thinking about Loonies. Loonies was one, and I think there was another one. But I really like Moon Dogs. Like I would love to be able to come in the chat and say, "What's up, Moon Dogs? What's up, Moon Dogs?" You know.
Oh, I saw Jenny had a name when she said hello to everybody when she came back. I'm trying to see where that was. Jen, let us know what that was again, because I kind of like what you said. I don't mean to put you on the spot. I just hope you remember what it was you said when you joined us again.
Yeah. It's starting to clear up. Very good.
Yeah.
He was right. Paul's on point, standing on top of that parking garage.
Mm-hmm.
He knows his stuff.
Moon Tribe, you call it.
Moon Tribe.
I like Moon Tribe.
Dog. I think I just want that just so I can do that drop.
I think so.
every time I come in, Moon Dog. ISS crossing 350 feet to 250 miles just fit nicely into Copernicus here. Yeah. Copernicus. Heard people call it that before. Copernicus.
I've heard that too. I think Bruce Cezal called it Copernicus.
Yeah. Copernicus.
Yeah. I mean, I can tell you that Nicholas Copernicus didn't call himself Copernicus.
God, I wish he would go live.
Bruce?
I really do, yeah.
See the vegetation in Archimedes. Okay. And
no, it's, you know, because, okay, let's say he happens to catch something.
Yeah.
You know what I mean? Like something legitimate.
Yeah.
And it's automatically going to be thrown into question because he's the only one that's seen it from the time, you know, the telescope to the camera before it was uploaded to the internet.
Well, as long as he captured it, that's fine. You know, look, and
yeah, but isn't that going to be the first thing, like coming from a MUFON stand? I mean, you know.
Well, I like the guy, but you know, he's when he puts up these streams, he makes these assumptions and then states what things quote are unquote. When you know he looks at some chromatic aberration and says, "Look, it's vegetation." It's like, no, it's chromatic aberration on your telescope system that's inferior. You know, I mean.
Well, I think he's seen, like, you know, it was like some green tints to some of the moon areas. You know, some very dull greenish, grayish, you know, areas like we shown earlier with the color.
And clouds.
Which I'll do that again since we're talking about it, just so people know what we're talking about. But it's kind of there's a haze above it, so it's not going to come in as good as it did earlier. But I'll overdo it just so you guys can get an idea. Now, if you were to look at that, you would say there's vegetation on the moon, right? You know?
No.
But I know you wouldn't. But
no, I understand the point. But you know, I mean,
he does do a lot of assuming, you know, and a lot of statement as fact that isn't really fact. But you know what? I have to give it because the guy. I mean, he's learning. You know, he's trying to make sense of what he's seeing, and for you know somebody, I don't believe he has any like formal education in astronomy and stuff like that. He's one of the amateurs, kind of like, you know, a lot of people that, are taking up just trying to find out answers, which I applaud him for.
Yeah, and I've mentioned a few things to him. I've written in there saying, actually, I don't think that's vegetation. Here's what it may be, most likely, and you might want to try investigating this or that or the other. And I've just never heard from him. I don't think I remember hearing from him anyway.
Yeah.
So maybe
he seems like a really nice guy.
I just think that he's at least passionate about it. I like that.
I told you before, I'd love to get him on, but I don't want to insult the guy. Like, I don't want to come off as insulting to him. You know what I mean? Like, I don't want to have him on and say, like, him say, like, this is what this is, and me say, no, I can actually, like, almost come off as, like, pompous. Like, I know what that is. You're stupid. You know what I mean? Like, I don't want it to come off that way.
No, you can't be like that with people. I mean, I know that.
No, I wouldn't be, but I just don't want it to come off that way because there's a very easy way to get misunderstood in your meaning of something. You know what I mean?
Yeah. Well, I mean, I can, in a sentence, I can make someone feel, like I'm doing that to them without meaning to either. Anyone can.
Yeah. That's two things I wish he would do. I wish he would, one, do it live.
Yeah.
And two, add a clock and a date. So it's at least time stamped.
Yeah.
So let's say if he does record it and doesn't decide to go live, at least he has a clock that we know what time it is. See, I mean, everybody that watches the stream, you see this little area to the top left. Okay. That's actually important information when it comes to, looking stuff up. That's the reason why I have it on the screen. We see that the moon is 98.5% illuminated. This is all stats from Miami. We see where it is in the sky with the degrees. Okay? So, it's in the southern sky, and then we know from horizon to horizon, which is the number below it, it's 46.41 degrees high.
Mm-hmm.
And that's stuff that you need, along with the time, to maybe find out what any certain objects are. You know what I mean? So that's why we have that on the screen, because I realized one day, people that have been here for a while know, what the stream used to look like. And this is stuff that I slowly added, realizing that, if we didn't have it, it'd be a lot harder for us to identify objects that possibly we can identify. And if we were going to send, like, say if we catch an object, and we've talked about this before, that comes in, jumps a 90-degree turn, and shoots off really quick, we need to have that peer reviewed. We need not just Mark to go over it, but once Mark confirms that, yeah, that's really crazy what happened, we send it off to colleges, to get them to analyze it. Mm-hmm. And they have all the information that they need, from the size of the scope that we were using, which is important, and of course the degrees and where it is in the sky, the illumination, and the time. Those are like your main points, and that's why we choose to keep them on screen. Yeah, it takes up a little bit of screen, but it's definitely worth having.
Yeah,
I like this, and I like that a lot of people have adopted that, actually keeping at least the clock on there.
Yeah, I have that too, and I did that because it was you and Build New York Skywatcher that actually convinced me to start streaming. Yeah, I mean, I built my observatory as a therapeutic thing for when I was recovering from my surgery. So I used it to actually retone my muscles and learn how to do all that stuff again.
Right.
I want to answer a question for I think it was Tim.
Okay.
Tim McKernan. He said, "Mark, are red dwarfs a good marker for extrasolar worlds with life?" Yes and no. Yes, because red dwarfs are the most populous star in our entire galaxy and likely other galaxies. There's more of them than any other type of star, and yet you can't see a single one with your eye when you go out at night. You need a telescope because they all are so small that they literally will fuse hydrogen into helium for 1 trillion years. Huh? Oh, okay.
No, I wasn't talking to you.
Okay. Yeah, so they
keep talking. I'll be right back.
They also have ultraviolet radiation sometimes that they give off, and M stars are known, especially the early ones, for giving off ultraviolet radiation that could be sterilizing to the surface of a new world. But you never know. I mean, we also know that this planet, one of the things that came out lately is that our planet may not be the best and most suitable planet for life, believe it or not. And you're thinking, wait, our planet? Yeah, our planet. There are planets out there that may be what are called super habitable. We're just habitable. And yes, on all the scales, we rank 1 because we base it on Earth and then go down from there. But there looks like there might be planets that are even more habitable than our own out there. And the James Webb might be able to help us. Imagine a planet, for instance, where you go and there is enough of a magnetic field such that you don't have to worry about high energy particles getting to the Earth, and we are shielded more from ultraviolet radiation, and so therefore no one gets skin cancer. The tectonic plates are more stable. There's no earthquakes, and volcanoes are pretty much done. So the planet could be in a point of stability where it might be somewhat of a paradise. Maybe the food chain is different there, and all the creatures are herbivores and aren't carnivores, so you don't have to worry about getting pounced on by a mountain lion if you're running somewhere. So it's possible that there are other planets that are super habitable like that, but we certainly don't know. But it's a theoretical thing that just came out. But I really like that question. But red dwarfs are probably the ones where we'd find a lot of planets. They certainly have the most planets of any other star.
Yeah, and Busta, we talked about the object from the other night earlier in the stream. If you go back, you can hear us talking about it about a half hour after we started?
Yeah.
Tana, Mark, to answer my question about the moon, what moon you think might have life and why?
Oh, I didn't answer that, Tana. Thank you. Well, there's a couple things. Now, our moon, no. Although we have water on our moon, we have confirmed that, but the water is locked up in the ice, of course. We have 3 potential moons in our solar system that we are interested in. I'll start with the most important one. Another thing just flew through. And that is Europa. Europa is a moon of Jupiter. It's around just under 2,000 miles across. I think 1950 miles or something. And it has an ice sheath, no atmosphere per se, but it has an ice sheath, and underneath that ice sheath is a deep ocean, maybe up to 60 miles deep. Now, here on Earth, we only have an ocean that's 7 miles deep at the deepest, and it's crushing pressures down there. But on Europa, which is not nearly the size of the Earth, you can go quite deep in the ocean before you feel pressures like that. So there could be a chance that there might be life there. One of the things we see is that there are geysers on Europa where some of the crustal ice has cracked and stuff from inside is spewing out into the exosphere, that is the area around Europa. And we see that there's hydrogen in there. There's water, of course. And we see some carbon dioxide. Now, if we see those things, it means that maybe those constituents, which are part of the building blocks of life, might also be producing methane, CH4, carbon hydrogen times 4, underneath that crust. And that is a very interesting finding, if possible, because that shows us that maybe there are smoker chimneys like we have in the deep ocean here that have a chemosynthetic life forms that are actually living off of the streams of methane that are coming out. And maybe that's some kind of life form that's possibly ubiquitous across the solar system. We don't know. And then the other moon that might have life for the same reason is Enceladus, a tiny little moon of Saturn. It's only 300 miles across, but we have actually mapped the hot spots on its southern hemisphere and its south pole, where there are underwater hydrothermal vents in the same type of potential chemistry going on down there. So, and then the third moon that's interesting in our solar system I mentioned before is Titan. Titan is sort of a snapshot of what the Earth was when it was just first formed, and so it's locked in the deep freeze. But if we could warm it up, or if there was a way to warm it up, I suspect that we would find that Titan would start generating the same type of atmospheric constituents that are here on Earth. It's heavily nitrogen now on Titan, but then again, so is our atmosphere. Think about it. And the oxygen is produced by life here on Earth, but initially it was produced by interactions with the upper atmosphere and volcanic outflows, outgassing and so forth. So that's possible. Now I think that we would find that there's a lot of interesting other places in our own solar system, and I'm really really hopeful that we'll study these. I'm really pumped by the possibilities of the James Webb, which is going up next year. And next year we'll say it's going up next year, and the year after that.
Well, it just got pushed back again, didn't it? To like 2021 or something like that.
Yeah, it's just like it's just endless. Yeah.
Take your time.
Exactly. Take your time. We don't really need to see what's going on in our lifetime.
Yeah, that's Yeah, I'd rather them take their time. You know, yeah, I'm in a rush. Like I want to see the stuff, but you know, I'd rather them get it right.
Yeah, I agree with that. And
I'll tell you what, we're probably going to go to 2:00.
Well, I'm going to say with that, I'm going to be heading out. I got a busy day tomorrow.
Mark has a busy day tomorrow.
I got to bid on a Navy project tomorrow and figure out what I'm going to do. It's this really cool automated Navy ship, which is really neat. So I got to bid on that and see what happens. It's kind of one of the first automated naval warships. It's really cool. Yeah.
Sweet.
Yeah.
Well, I'll tell you what, we'll say goodbye to you, and then I'll take a little break, and then maybe I'll come back and pull in a few people on Skype for the last half hour or so.
There you go.
And see what we can do. Well, once again, Mark, I want to thank you for joining me. Once again, we haven't done this for a while, so it's always good to have you on. Once again, I am pointing people to Mark's channel in the chat. There is a link. That is his channel. Once again, Mark, can you do me a favor real quick and just explain what you do on your channel to people that haven't seen it?
Oh, sure. I mean, it's a SkyTour live stream with Mark D'Antonio, and Amanda Curran is my co-host there, as well as SkyTour Radio on KGRA Radio. On SkyTour live stream, we do the following. Now, Keith and Paul do the moon and the planets. Bill New York Skywatcher does wide views, and we do something that's not that. We actually look at deep space objects, deep sky objects like galaxies, clusters, beautiful binary stars that have wonderful colors between them, like orange and blue, and many different colors. We look at nebulae, and then what I do with my astronomy background is I take pictures of these things, show them to you, image process them while telling you what we're seeing and how far away they are, what their importance is. And I basically try to educate people about the universe, because these are things that they don't see and they can't see except if they think to go look it up online. But if you see it live happening right before your eyes, it just takes on a whole new meaning. So that's kind of where I'm, that was my motivation for starting SkyTour Livestream, was the fact that, I wanted to have an observatory that people would be able to come in and hang out. And basically, it's a logical hangout. You come hang out, and if you can't watch it live, well, then you can go watch the replay, because it's obviously recorded.
Yeah.
So that said, I want to just say, thank you to you guys. And if you want to join me at SkyTour Livestream, that's wonderful. It's on YouTube.
And please do. And I'm not saying this is to blow smoke up his ass. You're actually getting live views right there, done live, of nebula and dual star systems, and not only that, but you're getting something that I should do more here actually, but you're getting it explained to you. You'll have a little music in the background and whatnot, but Mark will sit there with you the entire time and explain exactly what you're looking at, and all the complexities of it, and you can't help but to learn something when you're watching the SkyTour live stream. It just happens. And he also take requests. If you want to see something, like, hey, Mark, can we check out the Andromeda Galaxy? He'll shoot over there and do that.
Yeah, it's very interactive. That's the nice thing, sometimes people will look at the stream and kind of feel like, wow, I felt like I was running a telescope myself, because I suggested a couple places to go and we looked at them. It's really cool. And they like that. And I just think that people are hungry for science. They want to see what these things are. Maybe they didn't have an adequate science class. And I really think that would be something, I felt actually that would be a very good thing to add. So that's what we do. And we're looking forward to having, some folks with us on the stream. I mean, I've had Keith on with me, of course, and Amanda's my co-host. But I've also I'm looking forward to a few people. I've got a few folks that might be able to join us. And I got to tell you this funny thing. Actually, you know the Joe Rogan podcast?
Mm-hmm.
I was at a wedding, okay, and I started getting these texts. Joe Rogan just mentioned you on his podcast. Joe Rogan's talking about you right now. I'm like, what? Wait. And I went looking for it, and I never found it. I couldn't hear it. I couldn't figure out where it was because you got to wade through it. But apparently, he heard about what I'm doing too, and he mentioned it, which I thought was really kind of funny. You know, because my sons are big time into Joe Rogan, and they were like, "Whoa, that's cool,"
Yeah, his podcast has become really good. I mean, it's a lot of language, but still, it's because what I find fascinating about Joe Rogan is he used to be in this conspiracy pools, and it took him interviewing people like Neil deGrasse Tyson and stuff like that to pull him out of the, and because he was big about the moon hoax theory was the big one. Yeah. For the longest time, and it actually now to the point where he's like he'll tell you right to you that he enjoys a good conspiracy. But he's kind of like me that can't stand the ones that can be totally proven ridiculous, And he educated himself on it, and he can hang with the best of them, explaining why certain things aren't, and it's great. But what I'll do is I was going to say bye to Mark D'Antonio. Let's run down the list once again. We got the Sky Tour live stream on YouTube. We got Sky Tour Radio on KGRA Sunday nights at 9 p.m. We got NASA's Unexplained Files. We got What on Earth. We have a new one that was just filmed for Netflix. Do you have a name for that one yet?
Actually, that one I did in Arkansas. That was different. But then there's the new series In Search Of. And I did the first episode of that one so far. I don't know if they'll have me for more, but What on Earth is coming back to do the rest of season 5, either near the end of this month or into September.
Right.
So I mean, I guess like I said, people are hungry for the science. The conspiracy, the thought processes. What could this possibly be?
Yep.
Those are good questions to ask, and answering what it could possibly be is really a part of the answer that needs to be spoken.
And even if it's not the exact answer, like if you don't know the answer, you can give them plenty of options of what it could be.
Yeah, and I don't try to say this is what it is.
Right.
I mean, it's rare that I do that. I mean, except for like things like birds. I can figure that out. And know what they are.
Right.
But so it's cool stuff. I love it, and it's. I didn't go into this saying I'm going to become, this big time image guy. That's not what I did. I'm just very passionate about what I do. I love astronomy. I love to see what people do with astronomy. I love other people doing astronomy. In fact, Elliot Astro Imaging, another guy that we really like. He's starting up a beautiful stream up in Niagara, New York, in that area.
Yeah. He's getting his internet worked on now because
he is.
He figured that he didn't
100 down and 20 up. He's got a really good package from Spectrum.
Yeah.
And I just sold him one of my Astro cameras that was just gathering dust here, but was a very, very good, very expensive camera. And I just sold it to him to so that he'll have another camera that he can stream with that will be very helpful for him.
And once again, the more the better.
Yeah, that's right. The more the better. See, and we're in this as a family. We're all together on this. We're not trying to outdo each other. We're not trying to say I'm not giving that to Keith because then he'll have something I don't.
Yeah, we're not trying to pull a John Leonard Walls in here, people. We work together with each other. And just by I see a lot of people that are subscribed here are also subscribed to you, are also subscribed to Bill. And hopefully we can get that list growing, because once again, the more eyes, the better. It doesn't matter which screen they're looking at, or even if they're doing it themselves, the more eyes that we have, the better. Because we have had people, catch stuff that we didn't see live, and I'll look at the comments on that video, a week later, and all of a sudden somebody put down a time mark, and all of a sudden, wow, there was something in there that everybody missed.
Yeah.
So the more eyes, the better. Well, Mark, we'll let you go to bed. Thanks for joining me once again.
Of course, guys. Thank you all, by the way, for wonderful questions. I enjoy the interaction with all of you. It's really nice to see people who enjoy science the same way that we all do.
And once again, go subscribe to Mark. I'll post a link in the chat once again. Thank you, Mark, and we'll talk to you again soon.
All right, guys. We'll see you later. Thanks, Keith.
All right, bud. Thanks.
All right, bye.
Once again, that was Mark D'Antonio. Joining me as we normally try. We try to do it once a month where I have Mark on. And, we try to get some people's questions answered. Really good guy. And once again, a really, really good stream. If you want to learn. And it's amazing, like, when he does those long exposures of other galaxies and stuff, it's crazy. It's just amazing. But I'm going to hit the music for a little bit. I'm going to see if I can't gather some people for Skype, and then we'll jump back on here for the last stretch before we decide to knock off for tonight. And don't forget tonight, which is Saturday, probably we'll go on at probably about 10 p.m. or so, and then most likely we're going to go to daylight. So it's going to be a long stream tonight. So that's why we're kind of cutting this one at 2 o'clock. Plus, with there being a little bit more clouds around. And you can see the air got really active with the atmosphere scattering that light all over the place, making it look like it's underwater. So yeah, I'm going to see what I can do about Skype and whatnot and come back with you. Until then, enjoy some copyright-free music from our friends over at YouTube. You can win some, you can lose some, you know what I mean? But hey, at least they offer it. So if you don't like the music from YouTube, feel free to mute it and play what you want. Use your own soundtrack. And I'll be back shortly. Stand by.